So good evening all guys. So hope my voice is audible. Is it audible? Can I get quick confirmation in chat box? So good evening, Sukanya. So is my voice audible, Sukanya? Okay, what about my screen? Is it visible? Yes. I started 10 minutes early because I have to get ready with the virtual lab. Okay, so that's why I've started virtual lab. So by using this URL, that is osha-bits.codeargo.net. Okay, so it will show you three nodes here. So it is a multi-node system. The very first one is master. Second one is node one. It is nothing but a slave one. And second one is slave two. So totally we have three nodes here. So one is behaving like a name node and the other two are behaving like data nodes. Okay. So we have to click on start button. So after clicking on start button, so it will show connect button here. So what we have to do, we have to click on connect first. Okay, and then immediately it will show web console. Click on web console and then go to next screen. So click on slave one, again go to web console. Again the same thing we have to repeat with slave two also. So open web connect. So this is the very first step you have to follow, guys. And the next step immediate to this is, so click on terminal. So in terminal we have to check the IP address. So to check IP address, we have to type the command hostname -i. So this will give you the IP address of master. You can observe here. So it is dummy user master. So click on this. So it will show you the IP address. You copy this IP address and paste it in notepad. Okay, look at here. I am replacing this with the IP address of master. I've copied the first one. Same thing I have to do with two more nodes. So this is my dummy user node one. So here also I'm choosing terminal and here I'm typing host name I and I have to check with. Okay, sorry guys. I have to copy from here. I'm copying this and then I'm pasting on notepad. I will show you why I'm copying this on notepad. Okay, next I'm going to node 2. This is slave 2. So click on terminal. Again, type the same command. So host name I and copy this on. Copy the IP address of this and paste it on the same notepad. So you all can observe here. The very first one I've taken Hadoop master name. You're not supposed to leave space, guys. Space is very, very important. So this is the IP address of master, IP address of slave 1, IP address of slave 2. Guys, when you are going to start virtual machine, so every time you have to store these three values in host file actually. Okay, I will show you how to store it in host file. So go to master first. Go to master first. So on master, you just type sudo nano and then you have to give a path name of host. So host is present on /etc/host. So this is where you have host name. You double click on this. It will ask for the password. So password is cloud. Okay, type password. And then here, look at here. So here we have to configure all three nodes. Understanding my point? So what I'm doing here, I'm copying. First, I'm deleting this. To delete this, Control K. Control K is to cut the file and copy all three information and then paste it on host. Very simple. Okay. So all three data means all three IP address are present here. Next, Control O to save your file and then press enter, Control X. It will come out of the nano. So next, we have to do the same thing with respect to this also. So in node 1 also, we have to do the same thing because we have to communicate with each other, right? So for that reason, I'm storing all these informations. See, look at here. Here also, we have the same thing. So I have to copy So this is the initial configuration you have to do with all three node guys. Control X, and then I'm pasting the new IP address. So every time when you are going to switch on your computer, you have to do the same thing. Okay. And same thing with node 2 also. Same thing with node 2 also. It is asking for password. It is cloud. So after cloud, again copy the IP address. Control K for cut, and then right click, paste it. So after pasting, you have to save the file. Control O, press enter, and then Control X to come out of it. Okay, so these are the three things you have to do, guys. Otherwise, so master is not going to communicate with slave. Understanding my point? So to check whether it is communicating or not, you have to type ping here. So ping immediately. What is the name I've taken here? You just look at here. What is the name of your slave one? Hadoop-slave one, right? So you have to type Hadoop-slave one. Okay, once you are typing this, so it will start communicating. Look at here. So is it communicating? Yes, it is communicating, right? Same thing you can check here also, guys. So same thing you can check here also. Ping. And then what is the master name? Hadoop-master, M-A-S-T-R, master. You type this, it will show communication. Look at here. So it has started communicating. So once you are not storing IP address, okay, in three different nodes, so then definitely it won't communicate. So for communication purpose, this is the very basic setting you have to do before you are going to execute any of the HDFS command. So for this reason, I have started early. So anyway, it is recording. So everyone can go through this later. Is this clear? Is this clear? So Control L to clear the screen. This is the shortcut key. Control L. Okay. Okay. What is the time now? 5:48. Now it is the time to start our session. So till here clear. So those who have attended, till here clear. So once it is not clear, no problem, guys. You go through the recordings. You follow the steps what I have told you. That's it. So is this clear? So is my voice clear to everyone? I am not getting any responses. So this is the basic setting you have to do before you are going to execute your code, guys. So remaining all I will show you in the class now. Okay. So actually we are running on multi-node. You are asking me about to show on multi-node, right? So this is your virtual machine. Okay. So in this virtual machine, you can start working, guys. Okay. See, it is showing three nodes here. So you have to open three different terminals to open three different nodes. That's all. Okay. Now, okay, sir, we got the configuration done. So we are good. So thank you. Thank you, Raj. So don't try anything parallel to me, guys. First, try to understand the concept. I will only explain you everything. So later on, you can check with your comments. No, sir, missed. What you have missed, Tanya? Tanya, I'm not understanding. What you have missed? Sir, lab part. That you can go through recordings later. So see, I have to show some programming, right? So that's why I've started early and I've shown some configurations. That's it. So that you can see later. Okay, no need to worry now. So once you're opening your recording, then definitely you'll get it. Okay. So this is the very first setting you have to do, guys. That's all. Okay, guys. Yes. Hello all. Hello, my dear students. So welcome to our 7th session of the Big Data Systems course. So it is great to see you all again. So yes, today I'm diving deep into the world of big data, guys. So to kick off things, so let's remember why we are here. Okay. So as usual, guys, I'm going to start with one quote in every class. Today I've taken the quote from Thomas Edison. So what he has said, the chief foundation of the body is to carry the brain around. Guys, I love this because so it reminds us that our true power lies in our minds and our ability to learn and innovate. So let's get those brains ready for some exciting learning today. So you're all ready for today's session, guys? You all ready for today's session? Quickly, can you all confirm READY in chat box? Yes, I want a big ready and chat box, guys. Okay, thank you all. Let me open through my mobile. Yes, once again, guys. Mm. Yes, guys. Yeah, started by MS Teams online lecture. Okay, okay. This is the previous message. Yeah, I got so many responses, guys. Thank you for all. Yes, I'm seeing your energy today. Once again, guys. What's happening here? Let's start from the beginning. Where I have to search? Once again, guys. Yeah. Okay, guys. Yes. See, yes. So yesterday we have taken extra class, and in last class we have covered few topics. Is it? So let me share my screen. So can you all confirm once? So is my screen visible to everyone? So is this visible to everyone, guys? Yes, it is visible, right? Yes, guys. Actually, look at here. Last class, so we have discussed about the component of Hadoop architecture, and we have differentiated Hadoop 1 and Hadoop 2, and we have understood what is the benefit of using Hadoop 2 also. And we have jumped into the HDFS concept. So in HDFS concept, we have started with the architecture, and we have taken some examples also, and then we have jumped into robustness. And yes, we have left with introduction to secondary name node, right? So from here, we have to start in today's session. Okay, fine, guys. So yes, a few concepts we are discussing today. So let me start with the very first one, that is introduction to secondary node. So yesterday, some of my friend was asking question on secondary node. Sir, what is secondary node? What is the role of secondary node? Correct, no? My dear friends, so as you can see here, a major change in Hadoop 2 was the introduction of the secondary name node. So this is one extra node we have introduced in, one extra component. So we have introduced in Hadoop 2. Okay, that you should understand. So you just make a note of this, guys. This is the extra component. See, while the name node is a single point of failure, okay, the secondary name node helps with recovery. The main purpose of using this is, so anything happened to your name node, then we have to recover the data, right? So for that purpose, so we are using this secondary name node. Okay. The key thing to remember is that, so it is not standby name node. So don't think like that. Okay. And does not record real-time changes. So its main job is to perform regular checkpoints by merging the name nodes. Okay. So under name nodes, we have two things, right? What are those two things, guys? So one I have told you about FS image. And one more I've told you about edit log, correct? No? Edit log. Okay. So see guys, so what this name node is going to do, its main job is to perform the regular checkpoint by merging the name nodes, FS image, and also edit logs to create a new FS image. So it is going to create a new FS image. So this new image is then copied back to the name node. Okay, this will copy it back to the name node. So making it ready for the faster restart. So if a failure occurs. So this process is crucial for preventing edit log from becoming too large and slowing down the name node. So hope everyone understood, right? The main purpose of using this name node, the secondary name node. So this is the main purpose. Okay. So jumping to next slide, you can see here. So now I'm talking about high availability configurations of name node. Guys, now look at here. So for those you who want to dive deeper into robustness, so let's talk about high availability. Okay, high availability for what, guys? High availability for the name node. Guys, already I've told you about secondary name node, right? See, already I've told you about secondary name node, right? The secondary name node is a what? Good checkpoint mechanism. Okay, but it requires manual intervention to build up the what cluster in case of name node failure. So hope everyone are understanding now. Okay, so a more robust solution is setting up active passive configuration. Okay, active passive configuration. With what, guys? With the standby name node. With the standby name node. Okay, guys, both the active and standby name node keep their state synchronized using, see how it is going to synchronize, guys, for synchronization purpose. So it is going to use some messages. Okay, are you all getting my point, guys? So both the active and standby name nodes keep their state synchronized using a shared storage like quorum journal manager. So QJM, in short form, we are going to call it as QJM, or network file system. Okay, or network file system. Guys, here as usual, the data node sends heartbeats and update the both name nodes. I have told you yesterday, right? So, but guys, so writes to the what shared state only happen via the active name node to prevent what we call it as split brain scenario. Okay, guys, I think you all have heard about Zookeeper, right? So how many of them heard about Zookeeper? Maybe you have heard about Zookeeper, right? Yes or no, guys? So here, what we can use here, guys, so we can use Zookeeper. So this Zookeeper can be used to handle automatic failure detection and election of new active name node. Okay, so this is a very, very important point, guys. This is very, very important concept for enterprise level big data system. Enterprise level big data system. Yes, it is used for monitoring purpose. Of course, your answer is perfectly correct. So now look at the diagram. So look at the diagrammatic setup. What this diagrammatic setup is saying, guys, this diagram visually represent the high availability setup we just discussed. Okay, so take a moment to look at the image, guys. So we have here active nodes. See here, this is called as active nodes. And also we have passive name nodes here. And you can observe, so we have so many data nodes here. What data nodes are doing? So data nodes communicate with both active name node and also passive name node. Okay, And you can observe here, we have one more node here that is called as journal node, or we can call it as NFS. Guys, this journal nodes act as a shared storage for metadata. So this is act as a shared storage. So here I mentioned, right, shared storage. Let me write here. So this is shared storage for the what? Metadata actually. The active name node writes. Okay, active name node writes to the journal node, and the passive one, what passive one is going to do? The passive one reads from them to stay up to date. Okay, see, look at here. So it is reading, and this is writing actually. This is writing to the journal node, and this is reading from the journal node actually. Okay, because up to date information it has to maintain, right? Because of that reason, so we are using both here. So you also see zookeeper. See, look at here. So we have mentioned zookeeper here. Okay, so already I've told you, right? Zookeeper, which is used for failure detection. So this is used for failure detection. Don't worry about 3 or 5. Okay, I will tell you later. So once I'm teaching you zookeeper, then I will explain you what exactly that 3 to 5. Okay, right now it is not necessary. So this entire system ensures that even if the active name node fails, the passive one can quickly take over and providing highly available and resilient cluster. Understanding my point, guys? Then you are all understanding what is the main job of zookeeper. Yes or no? Ajit, you understood the main purpose of zookeeper. Yes or no, guys? Okay. Now let us discuss. So now let us discuss other robustness mechanism. Okay. So guys, you can observe here. You can observe here. HDFS is designed for what, guys? HDFS is designed for what? Robustness. All will agree with my point, guys. Yes or no? So HDFS is designed for robustness, right? Then how does it handle failures? Can anyone tell me? How does it handle failures, guys? Yes, any answer? Yes, very good answer. Very good answer by Ajit. Okay, the key lies in its replication strategy. Okay, so replication strategy, that is very, very important. When a file is uploaded, so HDFS breaks it into smaller chunks. That smaller chunks are called as what, guys? Last class I have told you, right? That smaller chunks are called as blocks. Correct, no? And replicas, and what it is going to do? It is going to replicate each block on multiple data node. So then what is the default replication factor? Yesterday I've told you, right? What is the default replication factor? Anumula, I told you, right? I will explain you later. What is that 3 or 4? I will explain you later. So right now I'm not teaching you zookeeper. So that's why I've not mentioned what it is. Clear? So I'm asking you some important question. What is the answer for that? What is the default replication factor? So in HDFS. It is 3, right? The meaning of this is 3 copies of each block are stored on different machines. Guys, this is very, very important point. So by default, it is going to create a 3 copies, 3 replicas. Okay. So based on this, there is a chance you can get a what problem in the examination. So that's why I'm repeating. Okay. So this redundancy ensures that even if 1 or 2 data node fails, the data is still available from the remaining replicas. Okay. So the name node continuously monitors the health of the data nodes through heartbeats. So if data node fails, the name node detects it and initiate the process of re-replicating the lost block to maintain the desired replication factor. So this is called as what, guys? This is called as what? So what we are going to call for this, guys? Yes, I'm getting, there is a delay in getting messages, guys. Okay, in my mobile. Actually, there is a delay. Okay, what we are going to call for this, guys? So we are going to call it as fault tolerance. Correct? No. Yesterday, somebody was asking what is the FT? FT is nothing but fault tolerance. So this is called as a fault tolerance, right? Okay, so now let us zoom those blocks. Okay, so what are those blocks, guys? So I just show you the robustness. So this is about communication. So communication part is very easy, guys. So easily you can understand this. So here we'll be having, yesterday I've told you, right? So TCP IP at network level and the remote procedure call abstractions on the HDFS specific protocol. So we are going to use RPC, remote procedure call, because we are using distributed computing here. So client can talk to HDFS using client protocol. Okay, data node and name node talk using data node protocol. So see, if a client is communicating means then client is going to use a separate protocol that is called as client protocol. And data node and name node are going to use data node protocol. So there is a procedure to talk to each other. And RPC is always initiated by data node to name node and not vice versa, guys. So it is not name node is going to talk to data node. So that you should understand. So that is the communication part they have explained here. So here, now I'm jumping into very, very important point. So what is that important point? So blocks in HDFS. Guys, I'm putting 3 stars here. 3 stars means this is very, very important for your examination purpose. Okay, so let us understand the concept of block, guys. Okay, unlike traditional file system where block sizes are typically small, but HDFS uses a much larger block size. So yesterday I've conveyed you, right? What is the larger block size here? That is 128 MB by default. Okay, so this is the crucial design choice, guys. So why so big? Yesterday I've given you the reason. Why so big? With example, I've given you the reason, right? Why so big, guys? Why so big? Yes. Yes. Very good. I'm not getting responses quickly, guys. I don't know what is happening here. One second, guys. Let me restart. See, there is a delay in getting messages. Okay, not an issue. Okay, yes, guys, as I told, yes, the reason I was telling you, right? So, guys, minimizes the, it is going to what minimizes the overhead of seeking and reduce the number of RPCs. How many of them will agree with my point? So with respect to communication also, it is going to reduce RPC and also it is going to minimize the overhead seeking. Okay, overhead seeking. Seeking means jumping from one location to another location, right? So in your memory, is it? So that is called as seeking. And allow for what? Efficient streaming reads. Efficient streaming reads. So these are the main purpose why we are using 128 MB here. Understanding my point, guys? See, for example, let me take one example to explain on this. So 250 MB file would be split into 2 blocks. Suppose you have a 250 MB means, so this 250 MB is going to what split into 2 blocks. Understanding my point, guys? Yes or no? See, for example, 128 plus 128. So how much it is, guys? 256. 46 is it? Then what about remaining? What about remaining? No, actually 128 plus 128, how much guys? So it will become 156, not 2. Okay. So 128 MB one block plus 122 MB another block, correct? No. So this is going to what occupy completely. This block is completely occupied and this block is not completely occupied. So this is occupied only 122 MB block. So the metadata for these blocks, so like their location is stored in the name node. Okay, the actual data, so as we discussed, is stored on the data node. Okay, the separation of data and metadata is the key HDFS scalability here. Okay, and you can work with this also, guys. So why this already I've explained you, right? The reason I've already explained you, right? Okay, so I'm getting so many questions. Sir, why 122 MB? Why 122 MB means, see, here I've taken, what is the size of my file I've taken here? Okay, here 256, right? Okay, so just I've given the example of what? 250 MB. Suppose you are storing 250 MB means then what you are going to do? Yeah, data for what? 250 MB. This is data for 250 MB. So 256 means not an issue. So 128 MB, 128 MB. See, complete blocks I'm going to get here. Suppose you are storing 250 MB block means, so then one block will go with what? 128 MB completely. Another block will go with 122 MB. Is this clear? So somebody was asking this question. Tanya. Tanya, is this clear? Yes. Okay, fine. So yes, guys. Yeah, good. So now guys, look at here. See, this is how you are going to check your block size. See, all of them, look at here. This is the command you are going to use to check the block size. See, look at here, guys. So HDFS, FSCK. So FSCK, and this is the file name I'm checking for. So slash sales jan 2009.csv hyphen file, this is the standard one, and hyphen block, this is the standard one. So this will give you the complete information about blocks. Understanding my point, guys? So this is the block name. So this is the block name. It is mentioning here, and the total size also it is mentioned here. So it is mentioning in bytes, guys. So it is mentioned in bytes, and total blocks it is created only one block. This will be always depends on the size of this data. Size of this data. Understanding my point, guys? So this is the number of data node. How many data node we have here? Only one data node. And how many racks it is created? Only one rack it is created. See, FSCK is the command to check block information. Rahul, it is a command to check your block information or disk information. Is this clear? So let me show you guys. For that reason only, I have opened my lab. I will show you in real time. See, look at here. My master is ready. One second, guys. It is taking some time. Yes, the password is cloud. So here we have to check whether that file is present or not, right? So HDFS, how to check this, guys? HDFS, DFS, and then minus LS. So minus LS will list you all the file. So where we are checking, guys? We are checking in root, right? So we are checking in root. So for root, we are going to use slash symbol. So what it is showing, you just look at here. It will list all the files present on your root. Correct? No. Let us check once. So whether it is listing all the files or not. Okay, what it is showing? Okay, connection failed. Why connection? Okay, I have not started with the this one, guys. So what is the command we are going to use to start this, guys? Start all.sh, right? I have not started with the JPS. Okay, let me start with JPS. Yes, it is not yet started. START start all.sh. So this will start all the daemons. Correct? Now this will start all the daemons. Okay. So as I told, guys, only you have to start from the master. That's it. So here you have a separate two nodes. So this is your Look at here, you can observe. So this is your node 1, that is slave 1. And we have one more node here. So multi-node I'm using today. So cloud. See, this is another node actually. This is your slave 2. Okay, what I'm doing here, I'm checking whether it is loaded all the daemons. Is it showing correctly, guys? Yesterday I've shown you the diagrammatic representation, right? So in master, it is going to load only name node, resource manager, and secondary name node. Correct, no? Is it showing correctly? And what about here? What about slave 1 and slave 2? What it has to show in slave 1 and slave 2? So once I'm typing JPS, what it has to show, guys? It has to show two things, right? Yesterday I've shown you in the diagrammatic representation. What are those? One is data node. Another one is what? Node manager. Correct? No. See, I'm checking in second node also. See, here also I'm showing you guys. See, it is showing data node and node manager. Correct? No, not name node Jyoti. So this is slave. In slave, it is going to load only two daemons. So one is data node, another one is node manager. So in master, it is going to load three things. What are those? One is name node, resource manager, and secondary name node. So is this clear to everyone? So whatever I've shown you in the previous class, is it showing the same thing? Do we need to start? No, I'm not getting that question. So here, okay, there is a delay. So do we need to start the daemons on node also? No, only in master you have to start the daemons. That's it. Okay, see, I have shown you some settings, guys. You go back to your recordings. In recordings, 10 minutes before I've shown you some settings. So once you are starting your virtual lab, you have to do all these settings actually. So then only it is going to show correctly. Okay, and it is required that first block should acquire full size 128. So or it can be 122, and the second block. No, first one should be always 128. Okay, first one should be always 128. Okay, second one always, last one should be always the remaining one. Okay, yes, it is OSHA lab. So I've opened everything in OSHA lab. Okay, this is everything showing on OSHA lab, guys. So now I'm trying to type the same command. I was talking about this command, right? What was the command I was showing you guys? HDFS FSCK. Let me show you once how it is going to work. So HDFS FSCK, and then so before that, let me show you once, guys, whether that file is present or not. HDFS DFS -ls, and then we have to check in root. So we have to check that file is present or not, right? So look at here, that sales Jan 2009 is present here. Okay, I have stored this block. So let me show you in user interface also. The same thing I'm going to show you in user interface. Okay, this is the user interface. You have to type the command localhost 9870. Okay, why it is not showing? So we have started, right? JPS. Okay, yes, it is started. What is happening with this here? Maybe it is clashing with old one. So let me exit this, guys. So in my system, I'm using one more, right? So maybe there. Okay. Sorry, guys. I have to show here, right? So I'm using virtual machine. I got confused actually. So here we have to open one web browser. So inside virtual machine, not outside virtual machine. So here I have to use the command localhost. What is happening here, guys? See here, localhost 9870. So once you are clicking on this, so click on, see here, look at here, guys. So it is showing all the information. So this information I will show you later. So you have to what? Click on this. See, it will show you the data nodes present here. So how many data nodes are present? What it is showing? How many data nodes are present, guys? How many data nodes are present? 2 data nodes, right? Correct? No, it is showing all the information. Look at here. Once I'm scrolling down, it is showing 2 data node informations. Look at here. And this is the non-DFS used capacity of this. See how many blocks. By default, we have taken 5 blocks here. By default, it will take 3 blocks, guys. But in this configuration, we have taken 5 blocks. So it is going to create 5 replicas. So even I can reduce this also. I can reduce it to 1. I can reduce it to 2. So we have not set anything, miss. By default, it will take 3. That is the meaning. So here they have taken 5 blocks actually. Okay, 5 blocks. And also look at here. Here I'm going to show you utilities. So in utilities, so it is going to list all the files. Look at here, guys. So is it listing sales Jan 2009.csv, input.txt? There are so many files are present here, right? Yes or no? Till here, everything is clear. So till here, everything is clear. So shall I get the confirmation and chat box? So now I will show you that fsck command. Okay. HDFS FSCK space. So what I have to type? I have to type the file name, right? So we have to type the file name. Look at here. So immediate to that. So we have to type the file name. What is the file name? Sales file name we have to mention. Same thing I'm using here. One second. So slash sales. Okay, press tab. Okay, it is not taking. Sales Jan 2009 dot CSV. The file name is CSV space CSV space hyphen file or files. So let me check once. Command is files and blocks. Correct? No? So we have to give the same thing. So files, FILES, files space hyphen blocks. So this command is crystal clear to everyone. Yes. Next, I'm pressing enter. Once I'm pressing enter, see, look at here, guys. It is showing all the informations. The block information, it is showing clearly. See, look at here. The same thing, whatever I've shown. So this is the block number. So total nodes, how many data nodes we have here? So we have 2 data nodes, correct? No? And how many racks we have? Only 1 rack. I will tell you rack, what is rack later. Okay, I will tell you what is rack later. And total size also it is mentioning in blocks, bytes, sorry. So it is showing in bytes. See, look at here, guys. All the informations are given here. So this will give you how many did. Otherwise, as I told, you can check from here also. So here also it is showing the same information. So once you are clicking on this data nodes, so it will show that same information. 2 data nodes are present, and these are the 2 data nodes. All the information it is giving. So hope this is clear to everyone. Yes or no? Is this clear to everyone? Yes. Any questions? Any question? Guys, actually, practical thing also I'm showing you guys. Because of that, today also I'm going to extend the class. No issue with you people, right? No issue with you people, right? Otherwise, I will show you the screenshots and then I will move on. Is it okay for you all? You don't want me to extend the class? Tell me at the beginning only. Tell me at the beginning only, guys. Because I have to show both. So programming part also I have to show, and then theoretical concept also I have to cover. Which one I should do? Should I extend the class today? Say yes or no. I'm not getting any responses. How much extension? Okay, I will tell you. Okay, half an hour or 1 hour extra class I'm going to take. That's it. Because I have to show all the practical things. 30 minutes should be okay. Then I will go quickly, guys. I don't want to waste time. Okay, so I think this and all you have understood, right? So next to that, look at here, guys. Next to that, so we have one more command. See HDFS on local. HDFS on local FS. FS is nothing but file system. So to find that, so we have to check this property. So dfs.data.dir. So this we can see in HDFS site.xml. Okay, HDFS site.xml actually. So now to see this, so let me show you once. To see this, what we have to do. So what we have to do? So we have to enter into this master. So minimize everything. Minimize everything. So click on home. Not click on home. Click on file system. So inside file system, so we have a folder name opt. Click on opt. Inside Hadoop. Hadoop, inside Hadoop, what is the next one? Share. Click on share. Again Hadoop, select the Hadoop and then tools. So inside tool we have lib. See inside lib we have all the files here. Look at here. All jar files are present here. Correct? No, all jar files are present here. But we are looking for XML file. So we are looking for XML file. To find this XML file, so you have to click on where you have to check. You have to check in etc, not in etc. So somewhere we have stored this. Go to opt, Hadoop. Inside Hadoop, click on data. So data node and name node both are present here. So this is going to give you the data node information. Data node information is not required to us. So we are looking for XML file, right? So where it is stored? Yes, here. So let me check with home. No, not here. So it is opt, Hadoop, inside etc, Hadoop. Here, see, look at here. All XML files are present here, right? So HDFS site XML. Let me show you. Let me copy this path, guys. So because you people have to search, right? Once again. Control C. I'm pasting this on your chat box. This you will get to know once you are installing your softwares, guys. This address you will get to know once you are installing your software. Otherwise, it is very difficult to search. And what file we have to search, guys? Which file I have to search? I have to search on HDFS site XML, right? See, look at here. HDFS site XML. See here, where is HDFS site XML? Here. HDFS, right? HDFS site XML. You double click on this. So there is no this one. Okay, I'm opening on page source. See, in page source, it is showing all the information. See, here we have done configurations. You're all observing. You're all observing, guys. DFS name.dir, DFS data.dir, DFS replication. See, here we have taken 3 replications. So actually, I've reset to 5. So by default, we have taken 3. I will show you today, guys, how to reset that. That I will show you. So here by default, we have taken 3, but we can reset that to 5. That I will show you later. But what I'm searching for, I'm searching for this DFS data.dir, right? The same thing I'm showing you here, guys. Look at here. What I mentioned here, DFS data.dir property. Okay. So here we have where we have to store our data node. Understanding my point, guys? Is this clear to everyone? Yes or no? So this is where we have our local FS. Sometime, yes, guys, instead of using DFS, so we are going to use FS also. That is also correct. That is also correct. Okay. And you can observe here. See, look at here. So this is the path we have taken. Inside data node, we have what current. So inside current, it is going to maintain all these directory informations. All these directory informations. See, whatever the data we are going to create, everything is going to maintain here. So for that reason, we have taken path here. Okay. So let me show you that. So this is the path we have taken for your dfs.data.dir. What is the path here? Opt, Hadoop, data, data node. So once we are giving this path, so it will go to that particular directory and it will start storing your blocks actually. So hope this is clear to everyone. Is this clear? Are you all getting my point, guys? Guys, I am not explaining everything in hurry. I'm going very slow to understand each and every. You people have to understand each and every point clearly. So because of that reason, I'm taking too much of time to explain each and every concept. Okay. And look at here. Now I'm explaining you on replica placement strategy with rack awareness. What is this replica strategy with respect to your rack awareness? What do you mean by this, guys? What do you mean by this? Can anyone tell me? Can anyone tell me about this, guys? Rack awareness. Look at here. So these are all called as racks. See, your node 1 is behaving like a rack, separate rack. Okay. So this is your node 2. So this is your node 3. This is your node 4. Okay. See, in this node 1, so we have different blocks. Look at the color, guys. So look at the color. So here we have block 1. So this block 1, so look at here, the same color one. Where do we have one more replica? So where do we have one more replica? So here, correct now, block 1. And here also we have maintained one more copy. See, this copy is maintained in 3 different nodes. Again, look at here, guys. This is block 3. Here also we have block 3. Here also we have block 3. Sometime, guys, you just imagine this is the rack. So inside this rack, so this is, let me call it as rack 1, rack 2, and rack 3. Okay, this is 3 racks. So first block B1 is going to maintain in rack 1, and B2 I can place in rack 2 also. Sorry, B1 I can place in rack 2 also. Other 2 replicas I can place in rack 2 also. Or else I can place in another rack also. Are you all getting my point, guys? This is called as rack awareness. So try to understand the concept of rack awareness. So rack awareness is also very, very important concept to understand the concept. See, the first replica is placed on the same node as a client. The second replica is placed on the node that present on different racks. See here, in different racks we have stored. Otherwise, sometime, yes, we are going to store in the same rack also. And third replica is on same rack as a second, but on the different node. See, rack can contain n number of nodes, guys. You just imagine one rack contain n number of nodes actually. So this is n1, this is n2, this is n3. So in real time rack means, you know, right? The same thing I'm telling you here. The same thing I'm telling you here. Okay. And for replicas greater than 3, nodes are randomly picked for 4th replica without violating upper limit per rack. So that is replicas minus 1 divided by rack plus 2. So this is another very, very important formula. So this, see, yes, based on this, there is a chance you can get a problem in the examinations. Okay, total replicas should be always less than or equal to number of nodes with number, means what? No 2 replicas on the same data node. So once the replica locations are set, pipeline is built and show good readability, reliability. And name node, what name node is going to do? Name node is going to collect all the block report, block informations from the data node to the balance the blocks across nodes. See, and one more thing, very, very important thing is, see, the very first time, what name node is going to do? Name node is going to push this replica to block 1. And what about another replica? See, this replica is pushed by this data node. So here, from data node to data node, we have a communication. So a second replica is created by this data node. This replica is created by this data node. So here onwards, guys, data nodes are going to communicate with each other. Can we modify and change the Hadoop directory path? So based on our requirement, yes, you can change, Pradeep, but my suggestion is don't change anything. So because it is containing what so many what configurations. So you are changing in one place means then you have to change in all places. So that's why my suggestion is in virtual lab, don't do any changes. Okay, you are installing on your own computer means then you do whatever you want. Okay, is this clear? That's why if one of the rack is not functional, replica will be present on the other rack. Correct. Your answer is perfectly correct. So from HDFS set.xml. Okay, is this clear to everyone? So now you are all getting some idea. So what do you mean by rack awareness? Yes or no? Yes, you can do that, Pradeep. That and all, that risk and all you can take. You have to search the current path and then you can do some changes. So can you explain formula again? So this is the formula. Look at here. See what I'm telling you here. Total replicas. Suppose you have 3 replicas. That 3 replicas should be less than or equal to total number of data node with no 2 replicas on same data node. This is the formula. Okay, here how many data nodes you have? So totally you have 4 data nodes, right? So 4 data node with no 2 replicas on the same data node. So that's why, so in our what diagrammatic representation, we have shown in different places. Sir, one rack has multiple nodes. Yes, you're perfectly correct. So here I have shown you, right? One rack can contain n number of nodes actually. Okay, so one cluster can contain n number of racks actually. One cluster can have n number of racks. So usually in your company, they are going to maintain this rack system, right? So in each server, they are going to maintain different name nodes. The same architecture we are using here, guys. That's all. So is this clear to everyone? So my dear friends, the default replica strategy is clever one here. So when a client writes a block, the name node identifies 3 data nodes to store the replicas. The strategy is to place the first replica on the node in the same rack as the client, and the second replica is placed on the different node in the same rack, and third replica is placed on the node in a different rack. So this rack aware replication strategy minimizes the inter-rack network traffic. Okay, so which is what one of the major bottleneck. Okay, so this is see this rack awareness replication strategy so minimizes inter-rack network traffic, so which is a major bottleneck. So by putting one replica in a different rack, so it also protects against a whole rack failure. Okay, for example, if a network switch for rack goes down, the balance between performance and robustness so is the key design to principle. So that is what we are understanding here, guys. So I think everyone understood this. Okay, so this concept is crystal clear, right? So what is rack awareness? The same thing I've explained you now. So is this crystal clear? Yeah, see here, I'm showing you the what rack. So rack 1 is containing node 1, node 2, node 3, node 4. So rack 2 is containing node 5, node 6, node 7, node 8. So rack 3 is containing 9, 10, 11, 12. See, each rack is containing 4 different nodes. So this blue color one is stored here. This is stored here. This is also stored here. And the green color one, see here we have 2 replicas. So here we have 1 replica. See guys, very important thing is what you have to understand here is, see first you are going to store this green color block in rack 3. This rack 3 is going to store another 2 replica in rack 1. That is very important. Okay. See this blue color one is stored first in rack 1 and the next to 2 blue color one stored after this, guys. So this data node is the responsible of what? storing these two what blocks in rack 2. And here, who is responsible of storing orange one? See, in rack 2, we have 7th node, right? So this 7th node is responsible of storing node 9 and also node 12. So you're all getting my point. Sir, I'm confused with the third line of the slide. Which line? I'm not getting you. Which third line? Third replica is placed on the same rack. Now we are getting right. Now we are getting with this picture, right? Gautam, can you confirm once? Now we are understanding, right? The same thing I'm explaining you in the next slide. That's it. So this is called as rack awareness concept. Okay. So now I'm jumping into the next very, very important concept, that is HDFS data rights. Okay, 1 second, guys. Okay, so can we take one small break now? So for 8 minutes or 5 minutes break, we can take no. Okay, so shall we go for 5 minutes break? So I'll come at exactly 6:50 and I will start with the next concept. Is it okay for you all, guys? Okay, fine. Thank you. So shall we start the session, guys? So I'm back. Okay, guys, look at here. So we were talking about the very important concept, right? That is HDFS data rights. Guys, this, see, once again, I'm telling you, this is very important topic. So I want you people to pay your close attention here. Guys, we are talking about the entire process of client writing data to HDFS. Guys, the process has three main stages. Okay, what are those three main stages? The very first stage is set up the pipeline. Once again, it is not writing. The very first one is set up pipeline. So this is the first stage. And the second stage is called as data streaming and replication. And third stage is called as shutdown of the pipeline. So these are the main three stages. And guys, look at here. Let's imagine a client wants to write a file. Okay, you just imagine. So client wants to write a file. So first the client contacts the data node, name node, right? Correct, no? The very first thing is client contact the name node. He is not going to directly contact with any data node. And he says, I want to write this file. Okay, I want to write this file. And it's going to split into what? Two blocks. Say block A and block B. So we are dividing it into only two blocks. So one is block A, another one is block B. You just imagine. The name node then figures out where to place the replicas for each of these blocks. And taking into account the replication factor and rack awareness. So both it is going to what keep in mind. The name node then provides the client with a list of IP addresses of the data node for the each block. So who is giving IP addresses to the client? So your name node is giving the IP addresses of the data node to the client directly. Understanding my point, guys? Yes or no? So now everything is clear. And for example, for block A, you just imagine. So block A, it might give the client list of data node D1, D4, and D6. So with this list, the client can now start the process. So with this list, the client start the process. So he's going to store this block A in what? Data node 1, data node 4, and also data node 6 actually. Okay, same thing with respect to this also, guys. See block B also. What kind of information it is received? Data node 3, data node 7, and data node 6. So based on this, so it is going to store all the informations. Okay, so is this clear to everyone? So now we are getting some clear idea. Okay, let me show you one by one, guys. So how to set up pipeline, then you'll get a clear idea. So here I have given the very first concept. Okay, let us look at the first step, that is setting up the pipeline. Guys, the client has the list of data nodes from the name node. So for example, block A, for block A, what it is, guys, for block A? So block A, it is data node 1, data node 4, and data node 6, right? And the client's job is to create a pipeline that will be what used to stream the data to all three replicas. See, look at here. You can look at in this diagram. So name node is giving information. Okay, this is your client. So HDFS client. So client is nothing but your JVM machine. So client is nothing but your JVS machine. So it is giving a write request. So I have to store block A. Then what name node is going to do? So name node is going to identify the free data nodes. And it is going to give the IP address of all three data nodes. And also it is going to create a what? Pipeline. So in diagram should be should there be name node also be in previous slide? Okay, which one you are asking about? No, don't worry about this, guys. This is not required. So I was showing you the pipeline, that's it. So here it is giving clear picture. Look at here. Here it is giving clear picture. So I've taken rack 1, rack 5 and rack 7. So inside rack 1, I've taken data node 1. So inside rack 5, I've taken data node 4. And inside rack 7, I've taken one more. Otherwise, see, look at here. So it is created two data nodes here only. So rack 5 is containing two data nodes here only. Understanding? So this IP address is given by this name node. That you should understand first. Okay. Next, look at here. Once it is getting IP address of this, the client first establishes TCP IP connection. Remember this. So TCP IP connection is established by the, who is going to establish the TCP IP connections, guys? Can anyone tell me? Is it data node 1 or data node 4 or data node 6? Yes, quickly. Already I've explained you this. So which node is going to establish the TCP IP connection? Data node 1, right? Data node 1, right? Guys, this data node 1, right? So I'm talking about this. See, this, it tells data node 1. See here. See, this tells get ready to receive a block of data. And by the way, here are the what addresses of the next two data nodes in the pipeline. So this data node is going to say, I am ready. And also it is going to show these are the two data nodes where I have to store the next to two blocks. Are you all getting my point, guys? Then who is communicating with this data node 6 and data node 4 and data node 6? Data node 1 only communicating with these two. See, this is communicating with this. This is communicating with this. Understanding my point, guys? So you're all getting clear picture. So how we are going to perform a write operation? Data node 1 connects to data node 4 and tells it to be what ready. Also providing it with a what? IP address of data node 6. Similarly, data node 4 connects to data node 6 and tells it to be ready. Once data node 6 is ready, it sends a readiness acknowledgement back to DN4 and also DN4, right? So once this is ready, it will send back what acknowledgement? Back to the what? This data node 4. This data node 4 send back acknowledgement to data node 1. Data node 1 will send acknowledgement back to the what client node directly. You're all getting my point, guys. Does it mean client node and data nodes same here? Yeah, sometimes it is same. Sometimes it is same. Okay, sometimes it is same. Sometimes it is different. So usually, guys, in usual setup, so the first data node will be behaving like our client. So this is directly communicating with client also. Look at here. Understanding? So hope till here everything is clear. This process ensures that all the data nodes in the pipeline are ready to receive data before the client starts sending it. That's all. Very simple. So what is the question? Data node 66. Why 66? Okay, by mistake she has typed. Yeah, acknowledgement will come back to like that. Yes, you are perfectly correct. So I think everyone understood, right? How we are going to perform HDFS write operation. Any doubts here? Any doubts here quickly? Quickly, any doubts, guys? See, all the information I have mentioned here, you go through this step by step. I have mentioned all. And next I'm jumping into next concept, that is data streaming. This is the second step, right? This is called as data streaming. Guys, the pipeline is set up and ready to go. Now the client start pushing data into the pipeline. Your pipeline is ready. So once pipeline is ready, now you got the what acknowledgement back, right? The client got acknowledgement back. So once he is getting acknowledgement back, so he will get to know, yes, this now everything is ready. Now client sends the data for the what? Block A. Data for block A to data node 1. You can observe here. Okay, block A is sent to data node 1. As soon as data node 1 receives the data, it start writing it to what? Its local storage. It will start writing on the what? Local storage. And at the same time, it start to forward the data to the
next data node. See, look at here. So immediately it will push. It is writing and parallel it is sending that data block to the what? Next node also. Okay, what is the next node here? Next node is nothing but data node 4. Similarly, data node 4 receives the data and it start writing it to what? Local storage, and parallelly it will start pushing that block to the what? Data node 6. Okay, this is the pipeline process, guys. The data is streamed from one data block to the next without waiting for the previous write to complete. So this is a very efficient way to replicate the data. So once the data is written to all three data nodes, so we can move to the final step of the process. So I think this process is crystal clear to everyone. Yes or no, guys? Yes or no? This process is crystal clear. Shall I get crystal clear on chat box? Yes. Shall we jump to the next node? What is the last process, guys? What is the last step? Shutdown pipeline or acknowledgement? Yes or no? So this is shutdown pipeline or acknowledgement, right? Okay, guys. The data for our block has now been copied to all three data nodes. But the client and the name node need to be what? Notice that the write was successful. So this is where this acknowledgement stage comes in. Okay, the acknowledgement process happens in reverse order of the what? Data streaming. Yes or no, guys? It is in reverse order, right? First, data node 6 sends acknowledgement back to the data node 4. Then data node 4 sends acknowledgement back to the data node 1. And finally, data node 1 sends all three acknowledgement. Okay, its own data node 4, data node 6 back to the client actually. So once the client receives this acknowledgement, it knows that the write was successful. Then see, after that, the client informs to the what? Name node that the data has been written successfully. So the name node then updates its metadata to reflect the new block and its locations. And finally, client shut down the pipeline and TCP sessions. So this entire process is repeated for every block of the file. So do you have any doubt on this? Please do ask me in the chat box, guys. I think everyone are understanding clearly, right? So the process is very simple, guys. I have taken 3 slides to explain the same thing. That's all. I have taken 3 different slides to explain this. Okay, 1 slide is enough, but I've taken 3 slides. Is it okay for you all? Shall we move on? Shall we move on? Yes. Now multi-block writes. Okay, now multi-block writes. One slide I've taken on multi-node, multi-block writes actually. Guys, just now we have discussed a large file is broken down into multiple blocks. So the clients need to write all these blocks to HDFS. Correct? No? This we have discussed, right? The good news is that the client will copy each block to its respective pipeline simultaneously. Okay. See, for example, if a file has 2 blocks, block A and block B, then the client will start the pipeline process for both blocks at the same time. Try to understand this. The pipeline process for each block is the same as well as we just discussed actually. This parallel processing of blocks is another key reasons why HDFS is so fast at ingesting what? Large files. Guys, this is happening parallelly. This is happening parallelly. Understanding my point, guys? So you can see in this diagram, the client is sending block A. Client is sending block A to one pipeline and block B to another pipeline. Okay, and these processes are happening in parallel. The end result is a what? Single file made up of what? Multiple blocks and each with its replica. So that replicas are scattered across the cluster. So is it interesting, guys? Is this interesting? Yes or no? This is what your HDF is. So you take multiple blocks. No need to worry, guys. Within a fraction of a second, it is going to what complete on. So this is one of the what interesting concept of learning HDFS. So I think everyone are feeling very interested, right? Yes or no? Quickly. Interested means type interesting and chat box. So this is the sample write code. Guys, I'm going to explain you everything in Java only, but I'm going to give you the alternate code later, guys. Okay, this is very much, see, we have a default what? A command. So in HDFS, that is called as put. So this complete function is equivalent to your put function. You people are not going to write anything. So but only the thing is you are going to type only put command, that's it. So by default, it will do all these processes. Yes, I have to explain the code, right? So that's why I'm explaining you the code. Okay, you look at here. The slide shows a very basic Java snippet for writing a file to HDFS. Okay, first create a configuration. See, look at here. First, it is creating a configuration object and set the default file system to HDFS. See, look at here. So this instance we have created here. Okay, and we have setting it to what? FS default FS we have taken here, and this we have set with HDFS. After this, guys, after this, so you then create a what path object to specify the path where you want to write the file. So immediately look at here. So we are going to use get configuration, and next to that we have taken the file name. After file name, we have taken the path where we have to store this file. The important line is this line, guys. File system create HDFS write path true. So this is very, very important one. Okay, this is the call that initiate the entire write process we just discussed. And it is going to return FS data output stream. See, look at here. So this function is going to return FS data output stream actually. Okay, so which you can then use to write data to the pipeline. Okay, you can then use buffer writer. See, we have taken buffer writer also. Buffer writer to write your text to the stream. Once you are done, you simply call buffer writer close. Once everything is done, so then you have to call buffer system close function. And also you are closing one more. See, this is buffer writer close, and also you have to close the file also. Okay, file also have to close, guys. So, and see, very, very important thing is the close method is what flushes any remaining data and informs the name node. That's the write is complete. Okay, so this is very simple code I have explained you in the Java, guys. What happens if partially written blocks in Hadoop? If the client crashes during the multi-blocks write? Aditya, then no need to worry. So it will take one more path. That's it. So it will take one more path of what? Rack, otherwise one more path of what? Another data node. So there it is going to store the data. See, every 3 seconds, so every data node will be what? Sending heartbeat to what? A node, name node, right? So once any data node fail, then immediately it will redirect to the another data node. That's it. Okay, this will happen every 3 seconds. Then how you are going to say there is a what failure in writing operation? Are you getting, Aditya? Are you getting my point? Okay, so everyone understood this, guys. So this is very easiest one, right? Guys, actually speaking, so this code I have explained you. So this we are not going to write in HDFS. So instead of this, as I told, we are going to use put command to store your file into HDFS. Okay, but background we have written this Java code. So this is inbuilt. Okay, so next to that we have one more HDFS create or write call sequence in code. Guys, look at here. This is another very, very important one. So now we are diving a little deeper into the call sequence for a write operation. So this is very important point about the anatomy of HDFS. Look at the diagram. Try to understand by looking at the diagram. Sir, do we have to write such codes in exam? No. That is what I'm telling you, Tanya. So I am explaining you how it is going to work. That's it, by using Java code. But as I told, we are going to use only put command. That's all. You are going to use only put command. Okay, look at here. But no, see, logic is important, right? So tomorrow you're going to modify any put command means, then you can use this. Understanding? Okay. Now look at here. Look at the diagram, guys. Look at the diagram. So the client makes, see here, where is client? So here we have a client, right? So client makes the number 1, create. Okay, create call on the file system object. So this is your file system object. The client first makes the create call on the file system object. And next to that, what do we have here? Second one. Second one, we have a file system, right? The file system object then makes a RPC. RPC means what? RPC, for what we are going to use for that? We are going to use it for communication purpose, right? So this file system object then makes RPC call to the name node. Okay, look at here. RPC call to the name node to create the file. The name node creates an empty file without any associated block. So initially it will create a what? Empty file. Try to understand this. And third step, the create call returns an FS data output stream. See, look at here. Here I have mentioned FS data output stream. I'm repeating, guys. The create call returns an FS data output stream. So this is the stream you use to write the data. Okay. As you write data to the stream, then the data stream component in the client JVM split the data into packets. Okay, it will split data into what? Packets. Try to understand this. So this is your networking concept. And puts them into the what? Internal queue. Again, it is dividing into packets and storing it in a what? Internal queue. And next to that, the data stream then requests the name node to allocate a new block and select the name node for the replicas. So this is where pipeline is set up. Okay. Understanding my point, guys? And one more thing, the data stream then streams the packet to the first data node in the pipeline. And then the data node then stores the packet and forwards it to the next data node in the pipeline. Okay. And finally, guys, the FS data output stream also manages acknowledgement. Queue of packets that are waiting for acknowledgement from the data nodes. A packet is removed from its queue only when all the data nodes in the pipeline have acknowledged receiving it. So this queuing mechanism ensures that the client is not blocked while the data is being written and replicated. So very simple concept, guys. So that you should understand. So what we have done here, so we have taken data. Okay, see, your HDFS client is created distributed file system, and then it will create a what? TCP to communicate with name node. Name node is going to create an empty file, and then it will return with what? FS output stream, and then it is going to what? Divide the data into what? Number of packets. Number of packets are going to what? Store in a data node. So once the splitted packets are stored in all the data nodes, then it will receive what? Acknowledgement back, and it will get to know, yes, this is done successfully. That's all. Very simple, guys. That's all. That is about write call sequencing code. Okay, the same thing I've explained you here. So with the 7 different steps, you go through this one by one. Guys, so we continue the same thing. Look at here. So here we have done with 2 steps, right? So this is step 1, this is step 2. So next we have step 3, step 4, step 5, step 6, 7. So here we continue with the what? Final step of the write process. when the client finishes writing to the file and calls close on the stream. So this is what happens actually. So this is what happens. See, we are calling close function. The close method flushes all remaining packets in the queue to the data node pipeline. Then waits for the acknowledgement from the all the data node to ensure that all the data has been written successfully. So once all acknowledgement are received, so it communicate with the name node to inform what? The writing of the file is complete. This ensures that name node's metadata is up to date and consistent. So you can see that sequence here, the same sequence we are receiving here. Okay. And final message is sent to whom, guys? The final message is sent to name node. What is that? Complete message. Okay. So this is when name node updates the metadata for the file. The entire process from the create call to the what close call is a highly coordinated sequence of events that ensure data is returned to HDFS in robust and fault tolerance method. So hope all these steps are crystal clear. So does the file system is written in a order of data node pipeline? Yes, sir. That is what I've conveyed you, Gautam. Initially, I've conveyed you the same thing, right? So it will go in order. That's why it is going to create a pipeline. So it will always follow the same pipeline. So data node 1 to data node 5, data node 5 to data node 7. That example I've taken, right? The same example is working here. Is this clear to everyone, guys? So shall we go with read function? Otherwise, can you all go with read function by yourself? So this is read function. So write once is explained you clearly. So this is read concept. So this is read code. Again, I'm explaining you what? Call sequence in code. Can you go through this by yourself? So it is very much similar to your write functions, guys. So can you go by yourself? Tell me one by one. So then, yes, guys, then I will jump to read optimization. This is another very, very important concept. So I have to explain you quickly. So look at here, guys, everyone. So there are a couple of optimizations that can be what used for HDFS reads. The very first one is short circuit reads. Okay, what this means, guys, if the client is running on the same machine as a data node. So one of my friend asked, right? So client can run on what? Data node also. So now the question is, if the client is running on the same machine as a data node that holds a block, the client can bypass the data node daemon and read the data directly from the local file system. Okay, so this is the huge performance gain as it avoids network overhead and TCP/IP stack overhead. Okay, this is the first point you have to remember. And the second, you ask the name node to cache certain HDFS path. Cache certain HDFS paths. So this is used for frequently accessed data. The name node then asks the data node to cache the corresponding block in their memory. Okay, so this allows for even faster reads for a lot of data. And finally, guys, finally you can look at here. So finally, we can also schedule client for data locality. Okay, the meaning of this is the scheduler tries to run the client's job on node that also holds the data block it needs. So this is the ultimate form of data locality. Try to understand this. Okay. And one more thing, guys, here I'm talking about security. Guys, let's what briefly talk about security in HDFS. Guys, HDFS support POSIX style file permission system. Okay, so this means you can set permissions for the owner. Okay, let me write here. You can set permissions for the owner. You can set permissions for the user. You can set permissions for the groups. Okay, and you can set permissions for the files and also directories, guys. Try to understand this. So it is very much like what your traditional Unix-like file system. In addition, HDFS also support for transparent encryption or decryption. The meaning of this is the data is encrypted on the file system, but applications don't need to know about it. The encryption happens seamlessly in the background, guys. It is interesting, right? By default, HDFS is doing encryption here. That is in background. HDFS uses the concept of encryption zones. Okay, where I have mentioned that. See here, I have mentioned encryption zones. So an encryption zone is a directory, and any file created within that directory is automatically encrypted with a unique key. Okay, a service is called the Hadoop Key Management Server. This is very, very important. Hadoop Key Management Server. So this handles all the key management. Okay, it provides access to store data. Okay, stored keys, create new keys, and decrypt keys for the what clients when they need to read the data. Okay, so these security features ensures that your data is not only available but also secure. Yes or no, guys? Yes or no? You all agree with my point? Now don't ask me questions. Sir, once you are distributing data in HDFS, so is it secured or not? So this is completely explaining the data is secured. Clear? Am I getting any messages? So here in mobile it is, there is a delay, guys. Okay. Okay, fine. Next, we are talking about file system. Okay, next we are talking about file format. Look at here, guys. This is the file formats. Guys, when you are working with the data in HDFS, you can store data in many different file format. So you can use simple text format. So that is like your JSON format, CSV format, so on and so forth. Okay. And these are human readable, but not very efficient in terms of storage or processing. Okay. So there are more optimized binary formats like Avro and also Parquet. So these formats store data in a way that is much more efficient for processing in a distributed environment. Okay. They are often columnar. The meaning of this is, so they store data by column rather than storing in rows. So that's why it is called as columnar. Okay. So this is a huge advantage for analytical queries that only need to read a few columns. Okay. And you can have formats like RC, that is record columnar. RC is nothing but record columnar. Guys, the choice of file system is very important and depends on your use case. For most big data analytical workloads, so columnar formats like Parquet are preferred because they reduce the amount of data that need to be read. Understanding my point, guys? So you people go through this ORC and sequence later. Okay, so now see here, text-based they have explained here. So bit by bit, I don't want to explain on text-based. So that and all you know, right? So this is sequence files actually. A flat file consisting of binary keys or value pair, that is called as a sequence files. Okay, this is mainly used in MapReduce concept. Okay, so and see here we have about three different types here: uncompressed key value record, record compressed key value record and block compressed key value record. Okay, so this is an key value pair, guys. That we are, see, once we are talking about MapReduce, then I'm going to explain you more on this. So these are all the example for storing images in the HDFS. Okay, I will give you this program in Python, guys. So I will give you this program in Python. So later on, you go and install, you go and store these images on HDFS. So I will give you the steps also. Okay, I don't want to spend time to show it in live. Okay, so this is ORC format. ORC format means optimized row columnar. So I'm giving you this as a homework. You just go through this. So this is the format we are going to use in big data system. This is one format actually. Parquet also explained here. I don't want to go with Parquet, guys. So all this you have to work by your own. So now we are working on basic command reference. So encryption and decryption will reduce the read throughput. Is it not, sir? Yes, it is. Yes, it is. But guys, actually, we are talking about huge amount of data. So in huge amount of, when you are going to store huge amount of data, so this delay is negligible. Okay. So shall we start with the commands, guys? So shall we start with the commands? Yes or no, quickly. Okay. So what you have to do, guys, you have to open virtual machine. So this is your virtual machine. Click on virtual machine. So once again, guys, so let me show you terminal. Open terminals, guys. So once you have opened terminal, as I told, you have to check whether your daemons are running properly or not. So for that, you have to type JPS, type JPS. So it will show all the daemons, okay, which is running on data node. So now what is the very first command, guys? Look at here. So look at this slide here. So I will explain you this later. First, look at here. What are all commands I've given here? So Hadoop FS, LS. What is the job? See, you can use Hadoop FS. Otherwise, you can use HDFS, DFS also. So both are allowable. Or you can use Hadoop FS also. Minus LS I have given. What is the minus LS means? So it will list all the files. Okay, it will list all the files. Correct? No? So that is the main purpose of using LS. So along with path also you can give, guys. Otherwise, you can give where you are looking for this LS. Okay, let me show you one example from here. So HDFS, DFS, minus LS. See, I am taking minus LS or hyphen LS. And then where I'm checking all these files are. Suppose I'm checking in root directory means. So then it will list all the root directory files. Look at here. So we have a folder here, right? We have output 123 folder, output 456 folder. Suppose I have to check their means, then you have to type that. So output 123, out 123. So this folder name you are giving means, so it will list files inside that 123. That's all very simple. And what and all information it is showing, you just look at here. So it is showing block numbers. Okay, it is showing this permission information. So what is D here? D is indicating for directory. So here directory is not there. R means read, W means write. Okay, this is group name. So group name is super group. This is username. Cloud is the username. And it is showing data in bytes. It is showing data in bytes. And then it is showing date, time, and then file name. The complete information it is showing on screen, guys. So this is the purpose of using minus ls. Okay, I think you're all familiar with what Unix commands means. This is same as your Unix commands. Okay, no difference. And what for you're going to use change mode? Can anyone tell me? What is the purpose of using change mode? Yeah, you have to change the permission means then you're going to use change mode, right? Alter the permissions of the file where see, we have to mention the values here. 777 555. You go through the internet, you search what is this 777 555. I'm not going to teach you the basic of what this number. Okay, you have to learn by yourself. Okay, so you have to mention that number. Immediately it is going to change the what? Permissions. Okay, and change owner. See, I've shown you, right? Just now I've shown you, right? See, owner information is given here. See here, super group, cloud. These are all owners. So this owner permission also we have to change, means we can change. So user to cloud. Yes, yes. Your answer is perfectly correct. Okay. So for that, we are going to use this command. One second, guys. And next to that, we have make directory. So make directory will create a directory. Okay, you can give path here, or else you can create inside root. Otherwise, you can create inside the directory also. Inside the root, inside directory, you can create it. So make directory is used to create a directory. And I've told you, right, write operation. Just now I've taught you write operation, right? So write Java code I've shown you, right? So this is the put command. This put command is used to store the local file to the what? HDFS. Here just destination is nothing but HDFS. Okay, you can mention path here. So inside HDFS, you have any folder mess, that path you have to mention here. So this is the local address actually. So where do you have that file? That address is called as local origin. So this is put. Get means to download the file from HDFS to local system. HDFS to local system. What is the question? I'm getting question. Put is for upload. Get is for download. Yes, yes, you are perfectly correct. So put is to write. So get is to read. Otherwise download. Okay. And what is this copy from local? Suppose in local drive, you have any of the file mess. So by using this, you can copy from local. Okay, here you have to give source address and this is destination address. And copy to local. Suppose you are copying from HDFS to local system mess, then you have to use copy to local. And this is case sensitive, guys. You have to use the same cases. Okay. And see, to create an empty file, you have to type this touch Z. So this will create the empty file. And cat is going to show the output on the screen. That's it. Cat is going to show the output on the screen. Okay, next to that, look at here. So these are all different commands related to your configurations. So you can use HDFS getconf. So this will return various configuration settings in effect. HDFS config related to name node you have to return means you can write name node. So returns name nodes in the cluster. So get configurations for config key means it will give you the value, return the value of particular setting. That is replication information it is going to display. And DFS admin report. So find out how much disk space are used, how much are free, how much are under replicated. All the information is to be what shown by this DFS admin command. Okay, all these commands you can use, guys, to create a file. And here, so here you just do one thing, guys. So what I'm going to do now, I have created all the files and I've stored everything in single Word file. That Word file I will share with you people. So can you all check with all the commands? So can you all give me quick confirmation and chat box? Or should I show any commands to you people right now? You want me to show any of the commands on the screen, guys? You people will check, right? And one more very, very important announcement. You are going to get one question on this HDFS command. So I'm going to give you the case study. Okay, for that case study, you have to write the HDFS command. So that's why before your examination, please do practice. Okay. Can you do practice, guys? Don't compromise yourself. Please do practice. So I'm going to share you one document, guys. In that document, I'm going to share you all possible HDFS commands with function. Okay. Okay. Should I show get and put? Okay. I will show you guys. No need to worry. So this is your, okay, once again, guys, let me show you this. So once again, guys. So here I'm going to create a file. So let me create a file name as nano test. Okay, test already created. I'm creating sample.txt file I'm creating here. So I'm going to copy some content from the internet. So I'm using some content, guys. I'm copying here. I'm creating some replica. So this is the file I've created. I'm saving this file. And then see, look at here. Once I'm typing ls, so it will show this file here. See, sample.txt is present. Correct? No? So this is present on your local system. Now what I have to do, I have to copy this file to HDFS. See, look at here. First, I will show you HDFS. So whether it is present or not, sorry, I'm showing outside, guys. Why I'm showing every time outside? Okay. So inside this, so let me show you here. Where is my name node? Yes, here we have a name node information, right? Look at here. So that file is not present. I'm showing you in utilities. So that file is not present here. Correct? No? Sample.txt is not present on your HDFS. So this is your HDFS, guys. See, look at here. The block size also it is showing 128 MB. The maximum block size it is showing 128 MB. So now what I'm going to do, I'm going to load. I'm going to upload that file to this. So what is the command? HDFS DFS put is the command we are going to use here. Put. So which file I'm copying? I'm copying sample.txt, right? So from local. Suppose you are storing from remote placements, then you have to give a path. So I'm typing sample.txt. Where I have to copy this, guys? So where I have to copy this? I have to copy this to root, right? See, I'm copying this to root. Otherwise, I will do one thing. I will create one directory inside the HDFS. HDFS, DFS. I'm using make directory to create a directory. Let me create directory name as, okay, let me take one name from here. So who is asked this question? Yuvraj. Okay, I'm going to take Yuvraj name only. So I'm creating folder name Yuvraj. So this is the folder name I've created. Okay, it is created on HDFS, but I have to give directory name, guys. So this is inside the root directory, right? I have to mention root directory. So then it will create Yuvraj directory. Okay, now look at here. I will show you on browser. Say I'm refreshing this. So once I'm refreshing, okay, so yes, 1 second, guys. Let me connect this. Yes, so look at here. So once I'm refreshing this, so it will show connected to, yes. So here, look at here, where is Yuvraj? Why it is not showing? So I'm inside master, right? Okay. So let me execute it once because I've reconnected. So already exist. Why it is not showing here?
Let me refresh this. Yeah, instead of refreshing this, I'm refreshing this, guys. So that's why this problem. I have to refresh this. So yes, to refresh I have. See, look at here. It is created folder name Yuvraj. So once I'm clicking on this, nothing is there inside Yuvraj, right? See, look at here. Nothing is there inside this. So now what I'm going to do, I'm going to copy that file. Okay, Control L for clear the screen. HDFS, DFS hyphen put, and then where I'm storing, guys, what is the file name I'm storing? Sample.txt. I'm copying sample.txt to Yuvraj. So Yuvraj is the file name I'm using here. Okay, this is where I'm storing inside the root directory. So once I'm pressing enter, so it will upload that file to this directory. So let me check once here. So let me look at here. So now I'm refreshing this. So once I'm refreshing this, so it is loaded. Look at here. Sample.txt is loaded here. Correct? No? Is this clear to all? Pradeep, Yuvraj, is this clear? Put command. Yes or no? From which local location this file will get upload? Yes. Very good question. Look at here. So that's why, guys, you have to click on, see, right now I am in the desktop. Correct? No, you type ls. So it will show this is the local file. So I am inside the desktop only, guys. That's why I'll copy it from here. Suppose you are there outside the desktop. Then what you have to do? You have to give complete path. Okay, how to take complete path, guys? How to use complete path? So you have to type desktop. I will show you guys the how to check with path. You type pwd. So pwd will give you the path. See, look at here. Home, cloud, desktop. This is the path. You come out of this and then HDFS. See, you are in different location. DFS. Now you have to give a path, right? Put command I'm using here. And then I have to give complete path. So I've copied that path. I'm pasting here. So inside, sorry, it is taking the content. Sorry, guys. Once again, I have to type again. HDFS. Okay, what is the path actually? Path I've copied, right? I think I don't copy that path. Let me copy that path. So this is the path I'm copying. HDFS, DFS, minus put, and then we have to take the source address. So paste it here. See here. This is followed by what? File name. Slash file name. Take the file name. What is the file name? That is sample.txt, right? Sample.txt. And where I'm storing inside out 1 to 3. Now I'm storing in different memory location. Out 1 to 3. See, now outside the what? This location, right? Then I have to give a complete path. Complete path of this file and then where I'm storing. This is the destination address. So press enter. So after pressing enter, you just cross check. So whether it is loaded. Here, look at here. Where I've stored inside out 1 to 3, right? You click inside this. So you look at here. So simple.txt is ready here. Okay. And one more thing, guys, let me show you the get command. Okay, here, look at here, ls. So sample.txt is there. No, right? That file is not present here, right? So now what I'm going to do, I'm going to download the sample.txt from the HDFS to local. So what is the command we are going to use? Can anyone tell me? What is the command to download? Yes, quickly. Give me the complete larger command, guys. So full command I want you people to give full command. HDFS, DFS, hyphen get, and then, so from where you're copying, that is the source address, right? Out 1, 2, 3 from this file. The file name is sample. sample, where you are copying? You are copying to the current directory. Current directory means what you have to type, guys? What is the destination? No, that is correct. But where is destination? Aditya, where is your destination file? Dot, right? So dot means current directory. So once you are good at Unix, then you will understand. So dot means current directory. See, it is downloaded. Okay. So no such file or a directory. Is it inside? Okay, sample.txt, right? I missed .txt here. .txt. We have to give the complete file name, guys. So .txt. Now look at here. I'm typing ls. So is it copied? Is it downloaded? Sample.txt. And you can use cat command to display the content. Sample.txt. See, this is the data actually. And inside this, suppose you have to check the block information means. Suppose you have to check block information means what command you are going to use, guys? This fsck command you are going to use? Yes or no? Fsck command is it? So do you have any file? Okay, so now I'm going to take the same thing. Out 123 slash sample.txt. So this is the file name I'm taking and I'm checking with the what block information. So press on enter. So it will show all the block information. Look at here. It is showing all the block information. See, 2 data node we have. Total size of the file it is showing. How many blocks it has been taken. It has taken only 1 block. Okay, it is in bytes, guys. So 2437. Actually 128 byte, right? The larger file size would be always 128 byte. So once it is exceeding, then it will go to the next one. And under replication block, it is replicated only once. See here, default replication factor, we have taken 3. So average block replication, it is showing 2. Because how many nodes we have? We have 2 nodes, right? So average, it will take the same data in 2 different blocks. That's it. So hope this is clear to everyone. Is this clear? You're all understanding what I'm trying to explaining you? Yes. So this will complete your 6th session concept, guys. So this will complete your 6th session concept. See how much time I'm taking to explain each and everything. I'm taking too much of time to explain each and every concept, guys. It is not so easy to explain each and everything in detail. Okay. So till now, everything is clear. Can I get quick confirmation and chat box? Sir, is revisioning, what is that? Sir, versioning supported. I mean, the file with same name is uploaded with different data. So it will save as version. No, file name is very, very important. Yeah, it will overwrite. It will overwrite the data. So once you are storing with the 2 different same file name means it will not allow. Actually, usually it will not allow. When you are going to type the command, immediately it will show the file name is already exist. Okay, you all try with that, guys. So that's why you have to try. Okay, you have to work on that. Then only you will get more knowledge. So shall we start now, guys? Should we go for another 5 minutes break? If you want me to give you break, I will give you, guys. So please give me 1 hour time. So maximum concept I'm going to cover in today's session. So here we have map reduce concept. So I'm going to show you a few output of the course. Okay, a few slides are demanding for programming again. So I'm going to show you few commands. Okay, few programs. So you want break means you go for 5 minutes break. So after 5 minutes break, I'm going to take 1 hour class. Is it okay for you all? Yes.
What about others? Pradeep, try to understand. So now I have to start with 7 session concept. Since we have less number of slides in each session, so I'm taking 1 hour extra class today, and next week I'm not going to take any extra class. So within 2 hours, I'm going to complete the entire syllabus. No need to worry about that. Okay. So today I'm requesting you people to give me 1 hour class. That's it. So let me cover how much I want. Okay. Thank you all guys. 5 minutes break. 7:55. We are coming back. So Niklesh, 10 minutes break means after 10 minutes, we are going to take 1 hour. Is it okay, Niklesh? So 8 to 9, I'm going to take the class. Is it okay for you all? You want me to give you 10 minutes break? So 8 to 10, I'm going to take the class. Is 8 to 9, I'm going to take the class. Is it okay for you all? Okay, fine. So I'm going to give you 10 minutes break, guys. So we'll start exactly at 8 o'clock. Okay. So 10 minutes break, I'm giving you all.
Yes, my dear students. So very warm welcome to all of you for our 7th session concept. So I am back, guys. You all back? So can you all quickly type? So once you people are back means back on chat box. Yes. Guys, last 1 hour I'm going to show you a few programming concept, guys. So I will try to explain you for a few programming concept. I will show you one program and remaining program I will post you guys. You have to go through each and every programs and you have to execute by yourself. Okay. Yes, guys. Let me share my screen. Yes. So now look at here, guys. This is the agenda for today's session. So this is the main agenda for today's session. So we have come a long way, and today, so we are going to put some more pieces of the puzzle together. And this session is all about two of the most critical component of Hadoop ecosystem. So one is Hadoop MapReduce, and second one is Yarn, yet another resource negotiator. Okay, so we will be starting by doing a quick review of MapReduce. So you might recall this from our previous sessions, right? So we'll then go on to the detailed walkthrough of a real world MapReduce program. Okay, this is the very, very important point. So I just explain you each and everything what are present in your MapReduce code. Okay, so let me show you the very first code, guys. So can you all remember this code? Can you all remember this code? Am I shown you this code on previous class? Yes or no? So let's cast our minds back to our few sessions ago. So we talked about sample MapReduce program, right? The goal of this program was to count the number of sales transactions by country from a large data set. So imagine we have a massive CSV file with 999 rows, is it? 999 rows, is it? So where each row is containing transactions and one of the column is country here. Look at here. So one of the column is country. So this column, H column is country here. Okay, which column is containing country? This is 1, 2, 3, 4, 5, 6, 7th column. Is it 7th or 8th column? Sorry. Then it has to start with 0. 0, 1, 2, 3, 4, 5, 6, 7. So 7th column is containing country, right? Yes or no? Okay, and our task is to find out, see, for example, how many transactions originated from India. So look at here. So here from India, 2 transactions, is it? So how many from Argentina? Argentina, 1 transaction. Australia, 38 transaction. Correct. Now this is what we have to calculate. Okay, trying to do this on a single machine with a regular for loop. So would be incredibly slow and inefficient for terabytes size data. So that's where MapReduce comes in. It allows us to parallelize this simple task across many machines. Okay, guys, this slide shows the snippet of what our input data might look like. So you can see columns. So transaction date, product, price, payment, so on and so forth, right? The output is showing here. So in black color, it is showing the output. Argentina with 1, Australia with 38, so on and so forth. So this is the simple but powerful outcome of MapReduce job. The magic lies in how the framework manages to get this done for you in distributed and fault tolerance manner. Okay. Shall I show this program for you people, guys? Shall I quickly run this program for you people? If you want me to show, please raise your hands on chat box. Otherwise, I will skip this program. Okay, already I've posted this program. How many of them viewed this program? I have posted this program on your Tuxila. So have you downloaded?
with the data set I have uploaded? Yes or no? Have you seen at least? So it is already posted. So I've created one separate experiential learning folder. So inside that folder you have, so did it on single node. What do you mean by single node? I'm not getting Ajit. Ajit, we have completely set of 3-node system. So completely set of 3-node system. Okay. So why we have to worry about that? See, it is the job of mapper. So it will distribute data to what different data node. See, only the thing is we have to run everything on single machine. That's it. So automatically inside that we have name node. It is the job of name node. So it will distribute to different data node. So setup and all already I've shown you, right? Okay. So you are saying you have did it on single node. Okay, fine. Not an issue. Not an issue. Standalone system is also okay. In real time, so it will distribute in what different systems. That's it. Okay, that is the okay. Maybe you are saying you have installed it on a single Linux machine. Correct? No, Ajit, am I right? Okay, quickly I will show you the command, guys. Quickly I will show you the command without delaying. So let me show you the command, guys. So this is my master node. So let me type cloud. So Control L, I'm typing Control L. Let me check whether my file is present or not. So look at here, guys. So this is my file. So where is this file? Where is this file? Where is this file? Okay, maybe it is in desktop. CD desktop. Okay, capital D, right? Capital D, yes. Okay, desktop. LS. Let me check once. Am I downloaded? Yes, it is downloaded. Look at here. Sales Jan 2009.csv is the file name. So this is reducer file. This is mapper file. Okay, only the thing is I have to run the code. What is the command to run this code, guys? I have shown you big command, right? Okay, one second, guys. I will show you the command is already there. No need to type anything. This is the bigger command. I'm going to explain you later, guys, but you people look at here. So first I have taken Hadoop, jar, and this is the jar streaming file name I have taken. So this will create the stream. Say I've explained you, right? So this file is going to create the stream. Okay, this is the responsibility of HDFS. Okay, what and all files I've taken? I've taken 2 files. What is the first file name? So I'm going to update each and everything, guys. Let me show you one by one. What is the file name? First file name, sales mapper.py, right? So this is mapper file. And next we have one more file name. What is the file name? Sales reducer file name. Look at here. I'm taking the same name. Okay, sales mapper, sales reducer file name I've taken. And here I'm running both the code. Okay, sales mapper and reducer I'm running here. So I'm taking sales mapper.py and here sales reducer.py. Sales reducer.py. And what is the input file, guys? So input file, it is already there on your HDFS. So what is the name of that file? What is the name of that file? Sales Jan 2009.csv. So it is a case sensitive. You have to what? Look at here. And where I'm going to store the output. Guys, I'm going to store the output on, what is the date today? Today it is 7/9, right? Okay. So let me write 79. Okay. So output 79 I'm writing here. Okay. Output 79 I'm writing here. So only this much path you have to give, guys. So let me copy this and paste it on your chat box. Okay. I'm copying this and then I'm pasting the same command on your chat box. Yes. One of my friend did that. Very good. See, this is what I'm expecting from you all, guys. Okay, so later on, see, once I'm doing this, so then I have to press enter. See, you have to observe here clearly. So I'm pressing enter.
So once I'm pressing enter, look at here. Okay, what it is showing? Something happened now. Python 3, somewhere I missed a space, I think so. Yes, sir. Sales mapper, something I did mistake. Where I did mistake? Here. Python 3, I've not left a space. So that's why it is showing error. Okay, so this is done. So now I'm pressing enter. So once I'm pressing enter, look at the screen. Okay, still I have error. So where I did mistake, guys. So this is always I'll do, guys. Where it is showing exception thread. So file sales mapper.py. Sales mapper.py does not exist. Okay, it is saying sales mapper does not exist. Okay, M capital. Sorry, guys. So in both files, M capital. So since it is case sensitive, so it will not allow me to what execute, guys. So what about reducer? Yes, it is capital letter. I'm using capital R. Here I've left space. We aren't supposed to leave space here. So delete mapper. And here also R capital. This is M, right? M capital. Okay, now I'm pressing enter. So once I'm pressing enter, see it is started executing. Look at here, everyone. So it is started executing. So I want you people to see here, guys. I want you people to see here. Where is mapper job? Yes, mapper job. Look at here, guys. So map 100%, reduce 0%. First, initially it is started with 0%. Why reduce 0%? It has to complete, right? It has to show 100%, 100%. So somewhere it is showing. Is it generated output file? Yeah. Let me check with the output. Later on, we'll get to know. So let me check from here. So whether it is created output or not. So where I've stored output 777, right? So it is created output file. I'm clicking on this. So once I'm clicking on this, see here, you can view the data. You can view data from here. So head of the file, you can see. So top 5 data. See, look at here. It is showing all top 5 data. But what is the file name I've taken, guys? Am I taken the country name? It is showing amount. Why it is showing amount? Which data set I have taken? Am I did any mistake here? Control L. Let me check. So sales Jan 2009 only I have taken. So let me check what is there inside that. Cat sales. Okay, so inside that, okay, one second, guys. HDFS, DFS minus cat. So inside this we have sales Jan 2009 dot CSV. No such file or directory. Is it not there inside HDFS? It is there, right? Sales Jan 2009.csv. It is correct only. Let me check once what is there inside that. Same data. The data is correct. Then why it is showing output, wrong output? So anybody encountered it? Sales Jan 2009 slash is not required. No, slash is not required. Sales Jan 2009 file name. Am I did any mistake with file name? Okay, let me check once. Control L. SALES sales Jan 2009 CSV. It is correct, no? The file name is correct, right? Case sensitive. Yes, I have taken the same name. S capital J capital 2009. S capital J capital 2009. Where is the file? Yeah. Sales Jan 2009.csv. It is correct, no? Where I did mistake? I'm not getting where I did mistake. Sir, out 79, out 77. Oh. I think I have checked output in wrong place. Correct, no? It is out 79. Oh, here I have to check the output. I have checked output in wrong place. I think so. Yes, it is showing correctly. Look at here, guys. So Argentina 1, Australia 38. I was searching in different place. That was the mistake I did. So it is executed correctly. Okay, it is executed correctly. I was searching in a different place. So now you are all understanding, guys. So now you are all understanding. Yes or no, quickly. Yes or no. Any doubts? Any doubts, guys? See, remaining all program I will give you guys. So many programs you have to execute. In today's session, I'm discussing so many problems. So all programs I'm going to give you guys with the data set. You people have to try by yourself. Okay. Otherwise, yes, I am also going to show you the output. I am also going to show you everything, guys. But yes, it is my request. So once you are executing, then you will be getting to know where exactly you are going to do the mistake. So that is the intention. That's it. Okay. So is this clear to everyone? Is this clear to everyone? Shall we proceed now? Shall we proceed now? Yes. The same thing I was showing you here, guys. So this is the output I was showing you people. And this is the next page. So this you have seen, right? This mapper 100%, reducer 0%. So this you have seen, right? The same statement you have seen, right? And this also I will show you guys. This screen also I'm going to show you. See, to see this, you have to take 1 second. Where is this? Yes. So I'm going to use localhost. Localhost 8080 will give you the name node information. Okay, I made mistake. Localhost. You type 8080, so it will give you the name node information. 8080. Unable to connect. Localhost 8080. Why it is not showing? It has to show, right? Last class I have shown you this, right? For you people. Or else you can give IP address also, guys. IP address of master.
Oh, now also it is unable to connect. Is there anything happen here? One second, guys. Let me check here. JPS. Oh, it is running. But why it is showing error? This is the correct command. Yes, now it is showing. Okay, now it is showing correctly. Look at here, everyone. See, it is showing 2 data node, correct? No, it is showing 2 data node. Okay, once you are clicking on this nodes, so it will give you all the informations. See, look at here, guys. So it is showing 2 data node information. Okay, so this is I'm showing you here. The same thing I'm showing you here. And it is going to see once it is running, it will show running. Okay. Let me execute this and immediately come back here. No, actually, it is failed. This time this is failed because I have not changed some commands. I have to change the folder name. Oh, it is disconnected here. So this is the problem always we will see, guys. It is disconnected. Simply, we are not running any code means it will disconnect. But yes, guys, it will show running here. So container status. So that is, it will show running. So once I'm getting that window, I will paste it to you guys. Okay. So now it is simply I'm wasting time. Okay. So hope that concept is clear to everyone, right? This is clear to everyone, right? So it will show running. That I will show you later. The name of the file, everything I will show you later. Okay. So that is there inside application jobs. So maybe yes, it is in application. Let me search at last. Where is applications? Yes, here we have applications. Running. Okay, it is not showing correctly, guys. I will check it and come back to you. Huh? So now I don't want to waste time. Okay. Yes, that I will show you later. So now look at here, guys, everyone. So this also you have seen, right? So once you are scrolling that down and up, you are going to get the same information. So here, look at here. See here, all this information is showing here. So file system and MapReduce framework. See here, it is showing counter attempt, saved output, and this is local attempt. So everything it is showing in detail. Okay. And bytes read, how many bytes read. So all the information is showing here. Okay, this is the information it was showing there. So this is completely MapReduce statistics, guys. Okay, this is completely MapReduce statistics. Okay, so after your job completes, So guys, Hadoop provides a wealth of information about its execution. So this slide is showing the example of kind of matrix, means a matrix you can get. So it is not about the final output. So it is about understanding the performance of your job. That's it. Okay, look at the counter value. So it will show, see, job counter. It is showing file system counter and job counters. So all these information, so you are going to get here. Okay, so file system counter means what? See here, so this is going to tells us how many bytes were read. So from the HDFS and how many is written to HDFS. See, look at here, how many of them read, how many of them written, all the information it is giving. So this is a great way to verify your job is processing the amount of data you expected. So then we have job counters here. So this is going to tells us how many map tasks were launched. See, look at here, how many tasks. So two mapper task is launched actually. So one reducer task is launched here. So this is on data local, again two task. So all this information is to be what given by job counter. And next, look at here, map reduce framework. So this is map reduce counter. So this gives you the granular details like the number of map inputs, map input records, map output records. So reduce input records. So it will even tells you about the what shuffle bytes also. Okay, it will show you what shuffle bytes also. See here, shuffled maps. So shuffling I've shown you, right? So shuffling errors. So all the information it is showing, guys. Okay, so now, so we are refreshing our memory on the overall process. So let's get into the what nitty gritty and unravel code itself, starting with our driver class. So this is the driver class I'm showing you here. I'm showing you this in three screens, three what slides. Okay, so this is not required. Again, I'm telling you, once you people are writing code in Python, so driver concept is not required. Already I've told you driver, right? Suppose you are performing iterative task means then you're going to write mapper main function. That main function is behaving like a what driver. You are writing code in Java means then it is compulsory. But we are not using this in Python. That's why I'm not going to show everything, but I have to explain the code. Okay, so I'm explaining you the code. That's it, guys. So every map reduced job so starts with this driver. Remember this. So you can think of this as a what main entry point of your application, just like your main function. So in regular Java program, the first thing we do is set up. So what we are going to set up here? So we are going to set up job configuration. Okay, so we are going to set up the job configuration. That you should understand. So job configuration object we are going to create first. Okay, and this is our configuration object for the job. See here, I'm creating that job configuration. Here, job configuration. So it is equals to new. Okay, and then we have sales country. Okay, we have written what sales country giving the what meaningful name for see, this is the name I've taken for good practice, guys. That's it. Okay, it helps you to identify your job in the web UI later. So next, we specify the data types for output key and value. So this is very much crucial. So remember, MapReduce works on key value pairs, right? So our driver needs to tell the framework what kind of data and final output will be. For our sales by country example, so the key will be the country name. So the key will be the country name and key will be the country name. So which is a what text object, correct? No, and value will be the counter. So these are the two values I'm taking here. Okay, so which is written in int writable. So which is written in int writable. Okay. here. So here we have taken the class, right? Int writable class. Look at here. Okay. So these are special Hadoop data types that are optimized for serialization and deserializations across the network. And think of the driver as a master controller of your entire job. It tells the Hadoop framework what to do. So what code to run and what data types to expect. And it is the blueprint for your application. Okay. So now look at here, guys. I'm jumping into the second part of your code, the continuation of your code. So now we are continuing with driver class. So after setting the what job name and output type, the next critical step is job conf object about mapper and reducer class. Okay, see here. So for mapper, I'm taking separately and reducer, I'm taking separately. Okay, so this is where we link our custom logic at the Hadoop framework. So we do this by calling job conf set mapper class here. Okay, set mapper class and job conf set reducer class. And passing, see what we are passing here. So we are passing the names of our classes. Okay, sales mapper dot class and say country reducer dot class. These are the two names we are passing here. Okay, another essential part of the driver is to specify the input and output directories of HDFS. See, we use input file and output file we have to mention, right? So for that reason, we are using these two lines. So file input format dot settle put paths and file output format dot settle output path. Okay. So the first argument is look at inside this. So the first argument is where the input data resides in HDFS. Okay, that is the path I have taken here. And second is the where Hadoop will write the final output. So this is where it is going to write the final output. So this is very, very important, guys. Remember, Hadoop operates on data stored in HDFS. So not your local machine's file system. So finally, submit the job to the cluster using, see here, we are submitting the job. So we are using run job cluster. See, look at here. So this line is very, very important. So this is the call that initiate the entire distributed computation. The framework takes over from here and your job is off and running on the cluster. And you have used a try-catch concept here. So you have used a try-catch concept because it is a good practice to handle any exception that might occur during the job submission or job execution. Okay, and here I'm showing you mapper code. So instead of explaining this mapper code, guys, so I'm going to show you my mapper code. Okay, mapper.py I will show you because driver code is not there. So that's why I did not show that to you people. I will show you mapper code from my system. One second. CLOUD. Oh my God. Control L. So you can type cat sales, right? Sales mapper.py, right? So this is the code I'm showing you guys. The same code you can use. Otherwise, the code I've given in Java, this also you can use. But you have to understand the code. That's it. So here we have written mapper code. Okay. So generally, I will tell you guys. So we are talking about mapper class. So this is where the real work of extracting relevant information from your raw data happens. Okay, what map phase will do? The map phase is all about parallelism. The Hadoop framework automatically splits your large input files into smaller chunks and separate map task runs on each chunk. Okay, the core of the mapper is mapper function. Okay, we are going to call map function here. Okay, look at here. We have written separately here, map function. Okay, this is the mapper I'm talking about here. Okay, so this function takes the input value pair and produces one or more intermediate key value pair. I will show you with the example. So here I'm going to show you with the example. Then you will understand. So this example will give you the what correct picture. Okay, about what mapper and reducer. So here I'm explaining with the Java code. That's it. Okay. You're understanding. So for our sales data, key would be the line number. So key would be always your line number. That's why we have mentioned here sales country of 7. Look at here. So this is the column name I'm taking here, and comma separated. Why I've taken comma separator? Because I'm using CSV file here. Because I'm using CSV file here. Understanding my point, guys? The same thing I've taken here, guys. You can observe here also. See, look at here. The same thing. Field of 7 and split of comma 1. See, initially what I'm going to do, I'm going to start from the line, guys. See, you have a file. So first I will go to the very first line. So in very first line, I'm going to confirm whether it is having transaction date or not. So once it is having transaction date, I will continue. See, inside try catch, I've told you, right? I'm writing inside try catch because any exception means it will handle by itself. So the very first thing is I'm dividing it into number of lines. And this strip is going to remove any spaces, extra spaces. So based on comma operator, I'm going to divide it into number of fields. Okay. And next, see field number 7. It is nothing but column number 7. It is going to take only the column number 7. And after that, so it is taking field number 1. You just go back to your data set. So field number 1 is required for us, correct? No. So both the data I've taken here. So after taking both the data, so I'm going to print country and also product. And see, the meaning of this is, see here, you can observe country comma product I've taken with count 1. So what is that? I'm creating key value pair here. I'm creating key value pair here. So after creating this key value pair, this input will go to a reducer. Let me show you. So I'm showing you cat what is the file name? Sales, right? So I'm showing you here, guys. Sales Jan. Output of this I'm showing you guys. So this is input to Python 3 space sales mapper.py, right? Mapper.py. Look at the output here. What is the outcome of this? Okay. I am on desktop. All these files are present here. Cat says Jan 2009 CSV dot. Okay, Python 3. Okay, this I have to mention it's a double quote. That's why it is not showing the output. What is the error? Python 3. Python 3 command not found. Okay, let me try with Python 2. My God, why it is not working here? It is not executing. I have executed before. I have installed Python 3. Before the class, I have executed all. Once again, guys. I don't know why it is not working.
Yes, it is showing correctly. Control L. I am pushing this file to Python 3. And what is the file name? Sales mapper.py. It is working. But why it is not showing output? Okay, I'll do one thing. cd dot dot. Here I have one more program. Let me try with this cat input.txt pipe symbol mapper.py. Sorry, Python 3 mapper.py. See, it is showing the output, right? So this is the output, guys. So this is the output of mapper. See, it is connected, means what? It is created a key value pair. So what is the key value pair we are getting here? Word. Along with that, we are getting value 1. The same thing we have written here, guys. The same thing we have written in this code. So actually, we are talking about what? That sales data. So sales data, we have to give the column name. That's it. So after splitting, it is assigning with value 1. So this is the output. See, look at here. India, 1, USA, 1. So India, 1. Like this, it is going to show the output. So is this clear to everyone? Is this clear to everyone? Yes or no? Quickly. Quickly, I want you people to confirm, guys. So grab before Python 3. Now Python 3 is working, Pradeep. So till here clear. Till here everything is clear. Shall I get the confirmation? So mapper function you all understood, right? So this is mapper and this is reducer code. So what reducer is going to do? What is the job of reducer? Can anyone tell me? What is the job of reducer? The reducer's job is to take all the intermediate values associated with the single key and aggregate them. Correct? No, that is the main role of what? This reducer job. So this is where the counting happens. Okay, this is where the counting happens. The core of the reducer is reducer function. So we have a what? Reducer function. So this reducer function is going to perform all the task. So reduce task. Am I right or wrong, guys? So it is, its input is a key and an iterator of values. For our sales example, the key would be the country name. The key value would be the country name. Look at here. You can observe here. So here we have taken the key directly from the what? Previous input. And then we are taking, see, here where I'm performing addition operation. So here somewhere I'm performing addition operation. Yeah, here, look at here. Frequency for country is equal to frequency for country plus value we get. See, value we are getting from the what? Previous file. So value we are getting from the what? Mapper file actually. Okay. So guys, for us, see what I said here. So that will take what? Value 1. Value 1 from the what? Previous one. So we iterate through the what? List of values and sum them up. So in case, so we are simply counting the number of 1. That's it. So previously we have seen, right, 1, 1, 1. See, India 1, 1, 1 means, so we are going to count the number. That's all. Okay. So frequency for country, as I told, frequency for country and each int writable value we get from the iterator, we add this value to value dot get to it. So once the loop is finished, so we have our final count for that specific country. We then emit the what? Final key value pair. The country name as the key and the total count as the value. So this is the final output for our map reduce job. So which is then returned to the what? Files in HDFS. Okay. So see, look at here. Collect function is going to write everything into HDFS file. Okay, this is the job, guys. So this is the job of
mapper and reducer. And look at here. So here clearly I mentioned map function separately. I don't want to explain this for you people, right? So mapper job already I've explained you. Whatever the concept I've explained you, I've mentioned here. So what is the role of map? What is the role of combiner, partitioner? Everything I've mentioned here. Okay. So what is the job of this, guys? What is this record reader? What is the role of record reader? This reads each record from the input split and present it to the what? Mapper. That is the job of what? Record reader. And it handles the low level details of parsing the data. So next to that, we have mapper function here. So mapper phase, where our user defined map function runs on each record and generates intermediate key value pair. It is going to generate intermediate key value pair. After mapper phase, so there is an option, but very useful step it is. So that is called as combiner. Okay, I will explain you combiner later. Combiner is also very, very important. So this is like your mini reducer. So this is like your mini reducer. So that runs on the what? Same node as the mapper. So it aggregate the values locally before sending them over the network. See, previously I've shown you word count program, right? See, for that word count program, so instead of what sending, so country comma one, country comma one, country comma one, the combiner is going to send, see here, hello.1, hello.1, hello.1 three times. So instead of that, it is going to show hello comma 3. So this drastically reduces the amount of data that needs to be shuffled across the network and saving a lot of time and resources. Okay, following to that combiner, we have a partitioner. Okay, this is crucial component that decides which reducer will receive which key value pairs. The default partitioner uses hash functions on the key to ensure that all the values for particular key end up at the same reducer. So this is very, very important point you have to remember. Okay, so the partitioner is what guarantees that country comma 1. Okay, country comma 1. I've told you, right? This hello comma 1, country comma 1. Pairs for India goes to the single reducer. So we can get an accurate final count at the end. That is the main purpose of using this partitioner. Okay, this and all you are not going to see, guys, but yes, it is very, very important. So once I'm jumping into reducer phase. So what is there inside reducer phase? The very first one we have shuffle and sort. Okay, this is most complex part of the process and often the biggest bottleneck. Guys, the shuffle phase is where the data from the what different mappers is copied to the appropriate reducers. So remember, guys, each reducer might need data from all the different mappers. Okay, the shuffle can even start while mappers are still running. Then after completion of that, it will jump to sorting actually, sort phase. So this is where the key value pairs for each reducers are sorted by key. All the values for the same key are grouped together so that reducer can process them effectively. And finally, we have reduce function. So finally, we have reduce function. So what is the role of reduce function? Already we have discussed, right? It takes the key and list of values and perform the aggregation. Okay, it is going to execute the aggregation logic and produces the final output. The framework calls new reduce function for each unique key. So after reduce key, guys, so we have output format. So this component takes care of writing the final output to the HDFS. So this is where the final key value pair are formatted and returned to the output file. Guys, this entire process for splitting the input to writing the final output is managed by Hadoop framework. Okay, your job as a developer is simply to provide a logic for the mapper and logic for the reducer function. That's all. So this is the beauty and power of MapReduce, guys. It handles all the complexities of distributed computing for you people. So hope you all understood what exactly all the functions are. Shall I get quick responses and chat box? If you have any doubt, please do ask me on chat box. So till here, everything is clear. So till here, everything is clear, guys. Yes, quickly, without wasting time. So let me jump to the MapReduce programming architecture. Guys, again, theory here. So let's take a step back and look at the bigger picture of MapReduce programming architecture. So imagine a data set, guys. You keep something in your mind. You have something data set on your mind actually. The framework's first job is to split this data set into multiple pieces. So what you are going to use here? So you are going to use split. The very first thing you are going to use split. Where is my pen here? Okay, first it is going to split the data. Correct, no? These splits are then assigned to the different worker process. So which is called as map task. Understanding my point, guys? So this will produce to map task. So these map tasks run in parallel across the cluster, and each map task processes its assigned split using map function you wrote. So it extracts relevant key value pairs. It extracts relevant key value pair. For example, in our sales data, the map task might be assigned a split of 1,000 lines. It processes each lines and extract the country and emits a what? What it is going to emit? Country comma 1, right? Country comma 1 is emitted. So this is the key value pair we are going to get from the mapper task. After this mapper task, so we have what? The concept of partitioning. That I have told you, right? The concept of partitioning I have shown you. Okay. So it uses partitioner function to divide its output into different regions or partitions. Okay. Each partition destined for what? Specified reducer. Try to understand this. See here, I have mentioned specified reducer. Okay. So, and this is crucial for ensuring all the values for the same key go to the same reducer. Once all the map workers are finished, the master process instruct to the what? Reduce worker to start. And each reducer contact the mappers to get the key value pairs for its specific partition. So this has happened in shuffle phase. This is happening in shuffle phase. The data received from the different mapper is then merge sorted by key. Okay. So after that, it is going to merge sorted by key actually. Finally, guys, after performing all this, so finally the reducer calls reduce function. It will call reduce function for every unique key. So this function perform the aggregation and the result is returned to the output file. So when all the reducers are done, completed its task, the master process transfers control back to your program and your job is complete. So the entire master worker process is what makes MapReduce so powerful and scalable. So you can visualize the entire task here, guys, by looking at this diagram. So whatever the concept I've explained you, everything is showing in this diagram. So this diagram will give you the complete MapReduce flow. Okay, look at here. So we have left side mapper task. Okay, so here we have input split. Okay, and it is feeding into what? Mapper function. The map function produces intermediate key value pair. So it is producing intermediate key value pair. Correct, no? And these pairs are buffered. See here, every time it is buffered in a memory. And when the buffer is full or splitted to what disk? Once it is full means it will go back to the disk. That's it. See here, splitted to the disk I have mentioned here. So this is where partitions, sort, and a spill to disk phase happens. So this phase organizes the data by partitioning and sorts it locally. See, you can see the red dashed line we have used here. Everywhere we have used red dashed lines. So this is showing fetching process. So which is a part of your shuffle concept. Each reduced task. Okay. So fetches its relevant partitions from all mapper task actually. And after that, it is going to perform merging operations. So look at here, we have a separate merging boxes, right? So this is showing in data. So this is going to do what? Merging options, and it is going to what? Sorted on disk actually. And finally, right side, we have reducer task. Look at here. So this is your reducer task. The sorted and merged data is fed to the reduce function. See here, the data is sorted and merged. So this will fed to the reduce function. The reducer performs its aggregation logic and writes the output to the what? Output to the output block. So this is your output actually. Okay. So other maps is fetching by what? Single reducer task. So this illustrates how the framework ensures that all data for specific key ends up at the what? Correct reducer. So this is the brilliant and elegant designs, guys. So now let me show you what the function. See, this is the diagram. So whatever the concept I've explained you, so everything I'm showing you in diagrammatic representation. See, this is similar to this diagram. Okay, one example we have taken here. So this is also very, very important for your examination. Try to understand this. This is very easy. Okay, here we have taken data sets. So this data set is divided into key value pair. Okay, this is in map 1, this is in map 2. And then again map 1, it is what? See here, how many we have here? It is sorted. Map 1 output it is showing here. Okay, why it is showing 2000, 4000? Okay, you have to analyze this. Why it is showing 2000, that you have to analyze. Okay, and then partitioning is happening here and reducer task is performing here. And finally, it is giving the output. So try to what? Analyze by yourself, guys. This is very easy to analyze. Okay. So this is one of the what example. And here word about combiner. So combiner is another very, very important concept. So already I've told you, right? I will come back to the combiner concept. I'm going to explain you. So listen to me quickly, guys. So in quick time, I'm going to complete this combiner. Okay. So combiner, see, this is optional. Already I've told you, this is not compulsory. This is optional. So it is localized reducer. That also I've told you, right? So what is the big deal? Guys, the combiner main purpose is to optimize the map reduce job performance by reducing the amount of data that needs to be shuffled across the network. Okay, it works by pre-processing the data on each map node before it's spent to the reducer. It's sent to the reducer. Look at the diagram. So in first example, see, this is the first example. Without a combiner, the map node produces key value pair like A, 1, A, 5, A, 3, B, 2. Okay, all these pairs have to send over the network to the reducer node for a key A. Look at here. It is sending to the key A. Now look at the second example. In second example, so we have taken the combiner. We have taken the help of combiner. The combiner runs on mapper node. Remember this. So it runs on mapper node. Okay, it takes these intermediate pairs and aggregating value here only. So it is aggregating value here only. Understanding my point, guys? You're all understanding what exactly the combiner is going to do. It takes the intermediate value and aggregate them locally and produces a single output for each key. So for example, see, this is not 5, guys, this is 9. So how much it is? 5, 6, 7, 8, 9, 10. Yeah, this is 9, not 5, guys. This is 9. Okay, A, 9 it is going to take. Instead of sending 3 key value pair over the network, it sends just 1. Okay, this significantly reduces the network input output. So which is often a major bottleneck in distributed system. Guys, this is a very important point. You can only use combiner if your operation is associative and communicative. Remember this. So once it is associative, so once it is communicative, then only you can use this combiner. Okay, see, for example, sum and max. So let me take the example of sum and max. Sum and max operations are both associative and communicative, right? Yes or no? So max of 1, 2, 3. So it is same as max of 1 comma 2 comma 3. Correct, no? But average is not. So if you try to take the average of local results and then average those, you will get the what wrong final answer. Okay, so that's that answer is giving here. That answer is giving here. Okay, so remember this thumb rule, guys. If the reducer logic can be applied to subset of the data without affecting the final result, so there only you can use combiner concept. So it is a simple change that can give you what huge performance boost. Okay, so that is what we called as optimizing performance. So this is going to what optimize the performance concept. So here, what optimizing performance also we have given in one slide. Okay, so with this, I'm going to complete today's session, guys. So this diagram is very easy. So with this, I'm going to complete today's session. You just look at here quickly. See here, I have explained you, right? Building on a discussion of combiner. So let's talk about some other critical performance optimizations in MapReduce. Remember our goal to achieve balanced maximum utilizations of the cluster, CPU and memory resources. There are two areas to look at what? Look at for optimization. So one is at partitioner, another one is at combiner. Okay, guys, first one is partitioner. Let me go with the partitioner first. So we know the default partitioner uses hash of the key to decide which reducer to send the data to. So this work well in most cases. But what if your keys are not evenly distributed? So this can lead to hotspot or data skew. Remember this. Okay, so where one reducer gets a lot more data than the what others. So this will become a what bottleneck. So in such cases, you might want to implement a custom partitioner. A custom partitioner allows you to use your own logic to distribute keys more evenly among the reducer. And it is going to balancing the load and improving the overall performance. That you should remember. And next, let me talk about the second one. What is that combiner? We just talked about this, right? So its main purpose is data compression. By running a mini aggregations on the mapper side, you reduce the data that needs to be what shuffled over the network to the reducers. So this is very simple and effective optimization as long as your operations is associative and communicative. So when you are designing a mapper and reducer, so don't just write a map and reducer logic. So think about intermediate steps. Okay, so can you use a combiner? Can I get quick confirmation? Can you use a combiner? Yes or no? So do you need a custom partition? Custom partition I will explain you later, guys. Custom partition also I will explain you. Concept I'm going to explain you. But yes, I want you people to use combiner. Okay, that is very, very important. Okay, so this diagram will show you the mapper and reducer concept completely. Look at here. This slide is showing another fantastic diagram of complete MR job execution, map reduce job execution. Okay, you just trace this. So we have HDFS split, HDFS split, HDFS split here. So this is the raw input data is partitioning into multiple chunks or splitting. So these splits are then fed into mapper phase. Look at here. It is fed into mapper phase. So each map task receives input key and input value pair from its split. Correct, no? So input key and input value is going to receive from the what different splits. The map task processes these pairs using map function. Then it is going to use map function and it is going to produce key 1, value 1, so on, key k and value k. Okay, so all these pairs are generated by this mapper function. And this is the intermediate data that we send to the what reducer. Correct? No. Are you getting my point? So then this intermediate data from all the mappers goes into shuffle and sort. Look at here, shuffle and sort. So this is the central hub of your process where the magic of grouping and sorting happens. The framework aggregates all the intermediate value by their key. So for single key, say key 1. So for key 1, so it will show all the intermediate values here. Correct, no? From all the what mappers. And finally, guys, so that will go to reducer, separate reducer. See, for key 1, it will go to separate reducer. For key 2, it will go to separate reducer. Are you getting my point? So, see, what reducer phase will do? Each reduce task receives key and intermediate value pair, and then reducer runs its logic and aggregate the values and produce the what? Final key value and also final value. So this final output is then returned to what? HDFS. So finally, this will return to HDFS. So this diagram beautifully summarizes the entire process and shows how data flow through the different stages. So it's great reference to what come back to when you are designing your own MapReduce job. Okay, so that's all, guys. I'm going to stop now because next you have so many examples. So this is sorting by value and min-max value. And next you have program and custom partitioning. Okay, and the n key given key value pair. So these are all the program. Totally, we have taken 5 examples. So with combiner also, we have taken 1 example. And exercise 6. Totally, we have taken 6 examples, guys. So these examples I will execute myself and then I will show you the output in the next class. So is this clear to everyone? So is this clear to everyone? Yeah, it is 9. Yes, I have corrected it. Okay, yes, guys, this is the theoretical concept. See, whatever the concept I have explained you, everything is shown in detail. So I have given more knowledge on mapper and reducer. Okay, so next class, yes, I'm going to show you all the examples, guys. I'm going to run all the examples directly. So before that, I'm going to post you all the programs. So is it okay for you all, guys? So is it okay for you all? Sir, does this complete the syllabus for midsum? No, we have one more session, right, Saini? So we have to complete 8 session concept, right? Sir, please share in. Yeah, I'm going to write everything in Python only. So I'm not good at writing Java programs. Okay, I'm going to write everything in Python. No need to worry. Okay, next class I'm going to I will come out with the what programs, guys. I will show you how to run all that 5 different examples. Okay, and then we have left with yarn part. I will complete yarn part and I will try to complete 8 session concept in the next coming class. Okay, there I'm not going to extend any class, guys. So 8 session we have very less number of slides, so I can complete the syllabus in the next coming class. Okay, is it okay for you all? So is it okay for you all, guys? If you have any query on today's session, please do ask me, guys. Yes, it is a completely vast concept I've explained you today, but yes, there is some repetitions, right? I have explained you mapper and reducer concept in detail. That's all. So for that reason only, I've told you. So I'm going with this. Okay, let me stop this. Otherwise, it will consume lots and lot of memory. Stop, stop, stop. We have to stop this, guys. See, it is consumed so much of space. Okay. So any questions, guys? How was the today's session? Yes, give me one line feedback. I have only 19 students. I think everyone left the class early. Yes, guys, it is too late, 9:10. So give me one line feedback. With that, we are going to what complete the session. Thank you for your cooperations, guys. Always, guys, you people are giving much cooperation for me. Sir, we can start lab as many as we want. Yes, Sani, you can start, but you have to check in your system Hadoop is working perfectly or not. Okay. So there is I have encountered with some problem. I have told them to what clear that problem. You try with that, guys. Once you have any problem, you send your mail to administration team. Okay, they will immediately respond to you people. They will come out with a very good what system. Okay, ready system. Okay, so otherwise you have installed on your system means you can try, not an issue. Sir, is there any limit on how many times we can access the lab? So here there is a limit, right? See, look at here. See here they have allocated only 20 hours. You have to restrict to 20 hours. So that's why I've stopped immediately. See, once we have switched on and then simply we are doing our job means here it is going to consume the time. So they have given only 20 hours. That's it. Already I have used one complete big data system. Now they have allocated me one new system. Okay. So almost 40 hours, 30 hours I've worked on this, guys. So how was today's session? Instead of saying thanks, so please give me one line feedback on today's session. So I am giving you what depth informations, right? So it is killing lots and lot of time. Meghna, Tanya, Tony, Niklesh, Akhilesh, Saumitra. Okay, guys, no problem. Session was interesting and understand the concept better due to diagrams, but bit long. Yes, it is long, lengthy and interesting. Plus labs were interesting. Nice hands-on. Thank you, Meghna.